Good morning, everyone. A warm welcome from eInfoChips. Thank you for joining this webinar on Robotics Fundamentals, Application and Future, Part 1, presented by eInfoChips and IESA Gujarat chapter. Today we have Dr. Nagendra Gajjar and his team with us. He is working as professor in Electronics and Communication Engineering Department since March 1998. He has an experience of more than 33 years in the field of teaching, research, and industry. He obtained his BE degree in Electronics Engineering from BVM Engineering College, Sardar Patel University, Vallabh Vidyanagar in 1990, an MTech degree in Computer Application from IIT Delhi in 2002. Dr. Gajjar obtained his PhD from Nirma University in 2013. He is serving as PG Program Coordinator, Embedded Systems since 2012. He has published more than 20 research papers in the area of embedded and VLSI design in international referred journals and presented or published more than 30 papers in international conferences and proceedings. He has guided more than 40 PG dissertations. He is guiding 3 doctoral scholars. He has successfully completed a funded research project for ISRO and DRDO. The ISTE National Award (CVM) Gujarat Award for Best Engineering College Teacher in Gujarat State was for the year 2005 was conferred on him. He was a member of Board of Studies in Electronics and Communication Engineering for Gujarat Technological University Gandhinagar, BVM Engineering College Vallabh Vidyanagar, and Sankalchand Patel University Visnagar. He conducted training programs in the field of digital signal processing, Python, embedded systems, MATLAB and image processing, cybersecurity for embedded systems, and reconfigurable computing for ISRO scientists and Navy officers. His research interests include VLSI signal processing, processor architecture, reconfigurable computing, high performance computing, and machine learning for embedded systems. He is life member of IEEE, IETE, ISTE, CSI, and ISRS. He has served as chairperson IEEE Communication Society Chapter, Gujarat section from 2014 to 2020. Currently, he is vice chairperson IEEE Communication Society Chapter, Gujarat section. Along with him, we have Dr. Darshita Shah and Akash Maikwad. Now, I would kindly request Dr. Nagendra Gajjar to continue our event by sharing his valuable knowledge with us.
Thank you for extensive introduction. I welcome all the participants on behalf of IESA Gujarat chapter and eInfoChips for this particular lecture series, online webinar on robotics fundamentals, applications, and future. So this particular session is divided into two parts. One is for day one, we'll be talking about robotics fundamentals and the basics of robotics that is needed. So along with me, we have, and day two, we will be having applications, some of the standards which is to be followed for the robotics and the future guideline and the interested students, faculty members, professionals who wants to contribute in the field of robotics. Will be showing them some of the futuristic guidelines where they can serve as well as contribute in this particular field. As mentioned, we will be a team of myself, Dr. Akash Makwan, who is assistant professor, as well as one of the key contributor or a technical person who is leading our Robocon team at Institute of Technology near my university. We will be having Dr. Jatin Dave, who is associate professor, as well as in charge for Center for Robotics and Automation at Institute of Technology near my university. We have Dr. Darshita Shah. She is mechanical department assistant professor. She is working in the field of robotics and contributing a lot as far as the theoretical, practical aspects are concerned. And then one another person will be Professor Vishal Vaidya, who is assistant professor, member of our robotics and Robocon team from electronics and instrumentation engineering department. So we'll try to cover some of the aspects which may help you to lead in the field of robotics and automation. And that's what will be our purpose for the day. So the day one proceedings will be something like this. I'll be talking myself, will be talking about introduction and overview of robotics, the global scenario, the working groups, the research, etc. Then types of robotics and key components of robotic systems, mechanical will be discussed by Dr. Patwari, and then design consideration challenges of robotic systems. Electrical electronic sensors will be discussed by Dr. Akash Makwan. So this will be day one proceeding. Just to give you overview, day two proceedings will be that is tomorrow. Once again, standards around robotics, the industry adopted interfaces and implementations, different types of robots, case studies and applications. So standards I'll be discussing, and types of robot will be discussed by Professor Vishal Vaidya. Case studies and applications will be discussed by Dr. Jatin Dave, and I'll be giving an overview of the technology which is leading the robotics in the field is robot operating system, and then future of robotics, as well as followed by your curiosity questions and answers. So these are the day one and day two proceedings for this particular webinar series to be held on January 2021. Okay, so the approach for this particular sessions, that's what I always used to tell everybody how you should look for is what, how, and why. So what is robotics? How robotics is playing the game? What are the key components? So that's what is the how part of it. And the final question is why? Why do we go for robotics? Right? So the applications and the future. So our case study. So that's how the presentation or a webinar series is divided into three components: what, how, and why. And for the students' point of view, I'll insist that you should also ask yourself any topic which you come across. What is it? How is it done? And why is it done? So this is what is in general. If you want to learn something new, you should ask these questions, and the answer to that question will definitely help you to understand that particular topic or content. Okay, so the first thing whenever we come across, we should have a kind of a thing is what is robot and what is robotics. So we must understand the definition of it. So look at the first definition. So especially particularly from the science fiction point of view, a machine resembling a human being and able to replicate certain human movements and functions automatically. So by now, even a layman, if you come across and tell a child of 5 years, then he or she also will say that, oh, what do we mean by robot, right? So the functional definition that we are giving is a machine resembling a human being and able to replicate certain human movements and functions automatically. This definition is little restricted. Nowadays, not only human, but we would like to mimic or replicate an animal also, or maybe a bird also. So we talk of a drone. Drone is also, we can call it as a kind of a robot, which is as if a human is flying and doing some task. Similarly, for the animal point of view also, we are trying to look into that, how we mimic some of the the animals and get the work done from the point of view where the movements are being taken care of and the functions for a specific applications. Later on, tomorrow we'll be defining about the different kind of applications. It's similar to a computer, we can say, right? Computer has a penetration across all different disciplines or faculties into the world, right? You name the area where computer is not being used, whether it is science, whether it is arts, whether it is law, whether it is engineering, right? Everywhere computer has penetrated into the human life. The same way the futuristic will look at it, robot is going to be entering into the each and every aspects of the life for improving the quality of life or quality of the people living, right? And that's what is the purpose of the technology. So the next definition, if you look at it, the second line, the robot and any automatically operated machine that replaces human effort, though it may not resemble the human being in appearance or perform functions in a human-like manner. So it's not, no, robot is, we cannot say that it is a humanoid. It is not the same shape of the human. We talk of industry, automotive industry, the robots are there. We talk of medical science, we have the robots which are doing surgery, right? We may have robots which are into the entertainment industry. We may have robots into day-to-day surveillance or a security. So you name the place. So it's not necessary. It has to be a robot which is looking like a human. Its appearance need not to be human. But we want to have the performance of that particular robot, which is a human-like. The next definition, the difference between the robot and robotics. So robotics is the engineering discipline dealing with the design, construction, and operation of robots. So here our purpose is to show you that what is the design of the robot that we are looking at. Then the construction, how the robots are being constructed, what are the key components. That's how the next two sessions will be telling you that what are the mechanical components required for the construction of the robot, what are the electrical, electronics, and sensors are the kind of a key components required. And then comes the operation of robots. So types of the robot depend upon the application domain, whether it is industrial, whether it is agriculture, whether it is medicine, whether it is entertainment industry, whether it is a security. So we have different domains of applications, and that domain of application will decide the kind of robotics that will be in need of. So the design, the construction, and the operations of the robot, and for that we need to have engineering faculty, and that will tell us that what the robotics is all about. So if you look at the other definitions based upon one of the key dictionary of the world, Merriam-Webster. So first thing is a machine that resembles a living creature in being capable of moving independently, as by walking or rolling on wheels and performing. That is one definition which is similar to the previous. The second one is such a machine built to resemble a human being or animal in appearance, as I mentioned, right, in the previous, behaving a complex actions such as grasping and moving robots, right? So if you want to say move the part or a weight from one place to another place, we'll say that we are using a kind of certain animals, and that animal behavior can be represented. Or say you want to climb the things from one place to another place. Just one simple example I would like to give. Recently, I had visited a Central Potato Research Institute at Simla, and they were interested in having an unmanned ground vehicle for the cultivation of the potatoes from the ground, right? But then if you look at it, the grounds over there, they are the hilly region, so they have the steps. So how do we move our robots which are used for certain conditions? So that's what is a machine that is behaving in form of human being or animal with a complex actions to be carried out. The next definition is a device that automatically performs complicated or often repetitive tasks. So this is what is now why now we say that at one place that we don't have the enough jobs, and by putting the robots in the place, we are reducing the number of jobs for the human being. But then one of the definition, if you look at it, when repetitive task is concerned, and then in that case is the human may fail in terms of performing for round the clock, right? You need to have a 3 shift, you need to have the people may have a fatigue, stress, and so on and so forth, or monotonicity for doing the work. In such cases, the robots are the best possible option. So that's what is very important, that a task is repetitive. We will be looking at a robot. A simple example, on a lakeside, you want to have a surveillance of the people that they are not sinking, or say the people are not going into the lake, right? You want to have a police, and police, if we can replace the police by robot, then that will be a good solution that we can offer. The next one is a mechanism guided by automatic control. So this is also one of the way of defining the robots, that they may be used for they are controlled automatically, right? And the new generation technology, all of you have heard about it, is artificial intelligence and machine learning. It's not that it was not existing before 30-40 years, but now because of the technology, the hardware and the software, we can have the robots which may have intelligence built in inside, right? You might have heard of humanoids being created by Japanese robotics companies, which can replace the human being and may have a kind of emotions associated with it. And that's what the last statement is, that a person who resembles a machine in seeming to function automatically or in lacking normal feelings or emotions. So normally we say that the robots does not have the feelings or emotions, but with the new AI, they are also trying to include this particular phenomena into the robotics. So that will be the kind of a next generation for you people to play with it. And that's what the last statement is. Okay, so now once we have designed a robot, there are few rules that is to be looked into, right? And that's how the people are worried about and trying to sort out the issues, that should we have a humanoids being used into the home services? Can we have the humanoids being used into the defense, into the army, right? Won't it happen that they may attack the human beings? So that's how the laws for the robots are being issued at ethical level. The number one law is a robot may not injure a human being, or through inaction allows a human being to come to harm. One simple example I would like to mention over here, at our university as a CRA, Center for Robotics and Automation, we have a 6 degree of freedom robot available. So if a human being is present near to the robot arm, it should happen that in any case, even something goes off, or say failure occurs, or say the electricity or a power failure occurs, even after that, the arm should not hurt the human being who is into the vicinity of it. Another example on the extreme right, you can see that this is an entertainment robot. Dog has been created for the kids, right? It has to be such that this particular robot which has been designed should not injure the human being. So that's what is one of the first law that has to be there whenever you are designing a robot. So it looks simple, right? You have designed, now you have taken a kit. For the students' point of view, I'm saying that you have taken a kit, you have created a small autonomous vehicle, and you call it as a robot, or say you are playing with it, right? So the thing is that you have to take care that by inaction of or anything goes wrong by that robot, it should not harm the human being. So this is the first law for designing any robot. The second law is that okay, a robot must obey the orders given it by human beings, except where such orders would conflict with the first law, right? So the second law for the robot design when you are doing is that must obey the orders given by human being, except where such orders would not conflict the first law. So I have given the order, right? The army journal has given the order, but that order should be such that it is not harming the human being. So that's what is that has to be taken care of. So that is what is the second law of robotics. And the third law is a robot must protect its own existence as long as such protection does not conflict with the first or the second law, right? So a simple example of this is now when you fly into the airplane, then they give a kind of instruction that if the air pressure goes low, you'll be having one air pipe flowing down. First, you help yourself and then only you help the others. So similarly, the third law says that the robot must protect its own existence as long as such protection does not conflict with the first and second law. So these are the three laws that has to be taken care of while you design any damn robot, whether it is any domain of application. So if we look at it, we have a kind of on the extreme right side, you have a big dog shape robot available. Now you say that I have designed a robot using a mechanical structure is there. We have electrical connectivity. We have intelligence built in inside. We have a control mechanism and so on and so forth, right? So here we are trying to mimic the animal behavior into a robot. But for designing that, we need to have a kind of a components. So what are the kind of a basic components required? So if we talk of a human being, we have a common five senses, right? So that five senses has to be reflected. And for that, we need to have some kind of a physical parameter to be properly understand. So we suppose, for example, we need to understand about the pressure. We need to understand about the temperature. We need to understand about the touch. We need to understand about the kind of air pressure or air waves. We have a number of different senses that has to be looked into, right? We need to look at a height, we need to look at a light intensity, and so on and so forth. So these are the kind of senses that needs to be taken care of. And for that purpose, you will be requiring sensors. The second thing is that you have sensed something and you want to take action on it, or say you have given the instruction to this particular big dog robot kind of stuff that it has to walk and it has to do the balancing by two legs, or maybe balancing on four legs, or maybe only balancing on one leg when it is running at a very high speed, right? So these are the kind of actuations that is required. So for that, we have a different mechanical actuations. We may have electrical actuations. So what are the actuators, the components that are required? The third thing is the computing. It must have a computing capability. It must have intelligence built in inside, and so on and so forth. And the fourth aspect that needs to be taken care about is control, right? So we, as part of engineering students, we learn about the analog controls. We learn about the digital controls. We learn about the control theory. So all that aspects comes into the picture while you are designing. So it's a kind of multidisciplinary aspects that needs to be taken care of. You need to learn about physics. You need to have a capacity of looking at chemistry. You need to have engineering. You need to have a kind of a psychology also, or a mimicking the behavioral aspects of it. So these all things has to be included when you design any robot. And definitely for the different domains and applications, the behavior, the kind of constructions, the design challenges, and the operating controls will be different. So if you talk about, say, for example, medical science or robots for the surgery point of view, then the requirement of sensors, actuations, computing, and control will be definitely different. If anybody has any questions till now, feel free if you can write it into the chat, or I'll go ahead in a minute. Okay, so some of the references for the hobby kits, if somebody is interested in playing with the robots, we have Adafruit Industries, Parallel-X, Robot Shop, Sparkfun Electronics, and VEX. These are the different companies. Within Gujarat, we have one small company which has come out of the kind of a hobby and competition base named as robotics, where the owner is also one of the alumni of Nirma University. So you can also look at from the local company robotics robokits.in for some of the hobby kits for the robot platforms. Some of the robot designs and instructions online, you can look at the websites which are the instructables. Let's make robots, make magazine. Then you have some of the autonomous aircraft, quadrotors, or flying robots you want to design. You can look at the do-it-yourself drones, robots.net, as well as the robotic club in Silicon Valley. So these are some of the references or websites for those who are interested in doing some work or starting to work practically into the robot field. Some of the best robotics programs in the colleges, you can go through this website. I have taken the references from this. We have a very long list available, but in general, the Carnegie Mellon University, MIT, UPenn, one of our alumni also worked at UPenn into the robotics area. He was our a lead for Robocon, one of the championship, and then currently he is with Tesla Motors working for the ADAS, that is automotive uh, driver assisted systems, a level 5 car he is designing at the Tesla, and he was alumni of Nirma as well as UPenn. Similarly, University of Michigan, Ann Arbor, which is Michigan, we all know that Detroit is a hub for the automotives. So there also they have two big companies who are manufacturing the automotive robots are Fanuc, and then we have a Georgia Tech also as one of the key universities. There is a long list. Just I mentioned about the top 5 at US. So what are the kind of work that these universities are doing? You can, again, into the robotics, you may have a different domain, as I mentioned. So wide array of fields, including aerial robotics, mining robotics, robotics for scientific discovery, search and rescue robotics, underwater robotics. So these are some of the areas which you can look into as far as the robotics are concerned. So these are the domains where CMU is expert and contributing, right? So the universities, you can go to the websites and find it out that which are the specialty. So see, the robotics is one of the things, but when we talk of the robotics, the heart will be, as a student, you have to be good at, or say you need to focus on sensors, actuators, control systems, as well as the computing platform. And the new domain as AI and ML, as far as the intelligence to be included into the robots are concerned. The institutes at national level, we have ISC Bangalore, Delhi IIT, Roorkee IIT, Mumbai IIT, Kanpur IIT, Kharagpur IIT, the Chennai Madras IIT, BHU Banaras Hindu University, BITS Pilani, IIIT Hyderabad, IIIT Allahabad, Manipal Institute of Technology, and as I mentioned, the Nirma also. So these are some of the universities which are offering a good platform as far as the robotics is concerned. Once again, I reiterate, it is a multidisciplinary, right? So it's not that you have a one course on robotics and you are through, right? You need to have a different courses that is to be studied, and we have to decide that, okay, I'm looking at the application point of view only. I'm looking from the design point of view. I'm looking from the construction point of view. I'm looking from a domain point of view. So the robots for the medical science versus the robots for the industrial. Again, within the industrial, the robots for the chemical industry versus the robot for the automotive industry, they all will be having a different domain. So the international scenario, I don't have much time to discuss about each one of them. So I have given the websites. So the scenario at Germany, the scenario at Japan, the scenario at Europe, right? Europe has a kind of a European Union. They have a robotics strategy. And so you can go through all these websites, and then the robotics at Australia. Similarly, there are a few more slides where you can look into the robotics for China and so on and so forth. So this is what the international scenario is all about. And as I mentioned further, if I want to classify, I can classify the robotics industry into the 50 different domains, right? So it's a huge growth possibilities are there as far as the robotics is concerned. At a national level, if I talk about, ISRO is working very strongly into the robotics. So they have developed a Vyoma Mitra humanoid, which is used for our Gaganyaan purpose. We want to send the space shuttle along with the human. So, but before we send it to with the human, they had done a humanoid experiment. Vyoma Mitra was designed. So the extreme right top, that is the picture of the Vyoma Mitra, which has been designed, and it was sent into the space in 2020, and they had done some kind of experimental results that they have calculated. The Mars mission was one of them, right? I have not mentioned about the NASA, but NASA has created a number of rovers and has been sent to the interplanetary missions, right? DRDO, we have a good number of labs available. One of the lab is a Center Artificial Intelligence Robotics. We call it as a CAIR, right? So that lab is working into the field of artificial intelligence. Let me try this to show you what the DRDO is offering and created the robots for the defense purpose. Just a minute. Okay. So see here. So they have a remotely operated vehicle ROV called as a DAX. And then we have an unmanned aerial vehicle named as a Netra. They have a confined space remotely operated vehicle CSROV, which is they referred it as a DUX Mini, which is a battery operated tracked vehicle with multiple degrees of freedom manipulator arm, telescopic arm, right? And it's not weighing more than 100 kg. Surveillance remotely operated vehicle on the verge of induction. So that is uh, the one another version of the DUX, and then they have unexploded ordnance handling robots. So these are the kind of robots that they have already created at the DRDO, and they have the technology cluster is SEE. So some of the students or professionals or faculty members who want to do some kind of a research and contribution and products, they can definitely explore the possibilities of DRDO website as well as the DRDO. So, and then BARC is also one of the organization who is also working in the field of technology implementation of robotics. So these are the three majors I have come across and I'm discussing about there. So this is the scenario of research as well as the products at national level. Now, if you look at the industry trends, see here, 2021, it is a $79.5 billion industry business. And the growth rate is CAGR, that is what is the commercial cumulative aggregate growth rate is being predicted as a 12%. So 12% is a good growth. See the 2030, they are expecting it to be $225.6 billion industry. So that's what is the robotics technology market. And in India, we are starting. So you are at the right age and the right time at right place with the kind of a policies of government that Indian Electronics and Semiconductor Association is leading and helping you all people to understand about the technology as well as focus for your growth path as well as professional career, and may have a startup in this particular field. So as I mentioned, it is market size currently is 89 billion. Possibility is 225. CAGR is cumulative aggregate growth rate is 12.29, right? And see the companies mentioned: Universal Robots, Boston Dynamics, Northrop Corporation, Omron Corporation. The Fanuc, as I mentioned, is very popular as far as the automotive robots are concerned. So these are the companies who are leading into the field of robotics and the robots at an industrial level. So if I talk about the trends, these are some of the websites which I'm mentioning about that what are the industry trends. So this is the second one is for the industry, industrial society automation, robotics tomorrow. Then we have IFR. This is also one of the International Federation for Robotics, right? So they are showing you some of the trends of robotics. So these are some of the websites which I've listed. Later on, you can go through and find out what are the trends as far as the robotics is concerned. So with this, I come to the end for my session of introduction to robotics, the national, international scenario, and the kind of a research and the trends as far as the robotics is concerned. I may take a quick one or two questions. I have 2 minutes to go. If anybody has a question. Yeah, any question? Yeah, one of the question is there necessary that robot should have a physical existence? Yes, it is. We say that it is physical existence. When physical existence is not there, we call it as a bot, right? If you talk about the Android, you might have heard of the companies are using a concept called as a bot, where there is no physical existence. So physical existence without that we got. Aren't the robot laws and their priority be relooked for say military fight uses? Military fight uses still that's what is the laws at international level has to be defined, right? Anyhow, still the law 123 has to be taken care of as far as the military aspect is concerned. Uh, what type of training should be given to robot in order to obey the second law? So it's not basically the training is AI and ML training part is coming up, right? But as far as the laws are concerned, it has to be properly coded, and that coding is the kind of a key component. And that's how for the general purpose, the next level of mechanism which has come up is ROS, Robot Operating System. So it should not happen right now. What happens is X company, Y company, Z company, they have their own rules. But if we have a common platform, and that's how the ROS has come up. The next question over there is how robot will know the opponent side person and not to injure the person on his side. So that's what is right now. The robot is not allowed to do any kind of a harm to a human person, even into the war. So if it has to offer or say destroy. It has to be tank or it has to be a kind of a missiles or something, and not the human life, right? So that's what the laws of robots are very, very important when you are doing any design. Actuation is a kind of a thing. A simple example is that I sensed a temperature, right? And I found out that temperature is high. I have to take my hand back, right? So the taking of my hand back is a kind of actuation. Or say if I have to climb on by the robot, it has to climb stairs. So then you say that the step size is this much, the step width is this much, and it has to climb. So that actuation means the leg has to be taken up. And for that actuation, we have some kind of a mechanisms of mechanical and electrical. So that's what we call it as actuation. Another example of actuation is I'm having a hand like this and I have to move my hand on the left or right. So that movement is, we call it as actuation based upon the command, based upon the control, based upon the kind of intelligence or a computing. So somebody has mentioned about the potential of robotics in defense. Very, very strong, powerful, and we have already have developed the robots for the defense, and already the companies at India level they are working. So you look at the trends, you will come to know. Okay, so thank you all for your presence. And if further questions, you can note it down, and we can take it maybe by end of the day or maybe tomorrow's session. Thank you, everybody. And now I invite Dr. Darshita Patwari. She will be talking about the key components and the types of robotics for the platform for robots. Yeah, thank you.
Good morning, everybody. Myself, Darshita Shah, working with the Mechanical Engineering Department since last 22 years in Nirma University. I'll be going to deliver talk on basic types of robots and the mechanical component utilized for the robots. I'll start my presentation with the introduction to the robotics, types of robots. I'll cover manipulator robots, classification of serial manipulators. I'll go through the definitions, basic definitions for the robots, then degrees of freedom, components utilized for the robot, that is mechanical drive and mechanical components. I'll go through the part of grippers and then safety and mechanical constraints applied to the motion for the robot. Then lastly, I'm going to cover the varieties of robot based on the applications. So here in this slide, it covers almost majority of the types of the robot. Say initial first row contains the basic robot type, that is manipulator robots. The manipulator robots are basically having a criteria that they are supposed to be fixed at a fixed base state, and whatever may be the requirement of application is there, based on that they can extend the arm and then perform the task. So they should have a fixed work envelope into which they can perform the task. Say first row indicates that these are the stationary manipulator robots. Say the task of robot cannot be confined to a fixed envelope or a work envelope. So next row indicates wheel robotics. Wheel robotics is a big broad classification of that is mobile robotics. A robot can move anywhere in the space and then it can perform the task. So mobile robotics have a single wheel robot, two wheel robot, three wheel robot, multi wheel robot, multi-directional, omni wheel robots. So that are the classification for a wheel robot. Again, mobile robots has a classification as a legged robot. Say we always try to have a robot to perform a task like a human being. So a human being or maybe a animal, or maybe it can be say that biomimetics. So legged robots are into the broad umbrella of mobile robotics, and in that one-legged, two-legged, three-legged, multi-legged, hexapod, or maybe insects biomimic robots are possible into the third row. And other robots are like say special purpose or specialized robot, which we can say that are emerging field in the robotics, are swimming robots, flying robots, robotic for ball for the aesthetic purpose, like moving moving ball or like a moving flower, just to entertain people. And another swarm robot is a emerging field in the robotics, like say there should be a team member or a commander and all other are the followers. So in robots also, if they are working together in a team of number of robots together, and out of them one is a master and all others are followers. And next say level is modular robotics. Modular robots can reconfigure their shape as per the requirement. They are most probably made up of the soft materials. Say another emerging fields in the robotics are micro nano robots, soft robots, snake robots. Say if it is required to go through the integrate part of a surfaces or like a pipe inspection. So a snake robot can move inside it and then perform the task of inspection or maybe surveillance, whatever is required. Say similar to snake robot, another classification is a clover robot. And sometimes it may be the combination of snake and clover robot, like a hybrid robots are also available. Say I'll start with the stationary robots. Stationary robots, or we can say that based on the work envelope, they are supposed to classify as Cartesian robots. Cylindrical work envelope will going to give cylindrical robots. Spherical robots, spherical work envelope. The SCARA robot can have a donut shape work envelope. Then articulated robot, which can perform all the type of industrial application task, and its workspace is depending on the length and dimensions of the arm, and it is not predictable. Another one is a parallel robot. I'll explain in detail what is parallel robot and what is serial manipulator. Here in this slide, it is going to give the classification of a robot, like say if it is a land rover moving on a land, if it is an aerial robot, or maybe an underground or underwater rover or a robot. So the broad classification is like say land rovers, underwater rovers, and maybe the aerial robots. Say in land rovers, it may be the wheeled operator or maybe the leg operated. Leg operated robots are having 2, 3, 4, 5 multiple legs are possible, and certain inspection dogs, or we can say that for the surveillance purpose, biomimic of a dog is available in the market, that are legged dogs. So four-legged dogs are available in the market, and the last one is a highest level of intelligence, like a humanoid robot, is also available in the market. Say another variety of robot, we can say that it's a hybrid structure of a mobile robot as well as manipulator robot. So manipulator robot is almost having a fixed base. They are supposed to perform a task based on the one situation only in a work envelope. But if there is a mobile robot, and if we mount a manipulated robot on a mobile base, it can have a criteria that the mobile robot can move in a space wherever it is required, and your manipulator robot can perform the task. So the combination of two, that is mobile as well as manipulator robot, is also there, which is going to give the required purpose. So here is a big classification. We can say that the mobile fixed base robot manipulators are having two basic types. One is a parallel manipulator, another is a serial manipulator. Say normally parallel manipulators are having one fixed base and number of linkages are there attached to it. So say number of series of linkages are attached with that. That will allow to move a movable base on the top. Or it may have a combination of more than one series of parallel robots. Like say in the right hand side figure, it is indicating that the series of two parallel robots are there. Say parallel robots are having a criteria that they can use for very high payloads, and they can perform a task as desired. And similar to that, say if a serial manipulator I consider, that has only one set of linkages to do the intended purpose. So we can say that number of serial manipulators altogether attached in parallel will going to give us a parallel manipulator. So this is the basic difference between serial manipulators and parallel manipulators. So while going through the literature, the serial manipulator and parallel manipulator word will be coming here and there, and so that's why it's very important to understand the basic difference between the two. So combination of serial and whatever maybe parallel manipulators are there, that can be the right hand side figure indicates that that is also possible for the certain applications where with very high payload and very intricate task. We can go for having combination of both. Here is the classification of robot based on certain categories. If we consider the robotic arm geometry, based on the robotic arm geometry, we can have a classification of that as a rectangular robot. Cartesian robot is a rectangular robot. Then cylindrical robot, spherical robot, jointed arm robot, and a SCARA. SCARA is a selective complex assembly robotic arm, and it is very important industrial applications, and it is very famous. And nowadays in so many industries, the people are using SCARA for pick and place applications. Another robot classification is based on the degrees of freedom. That means the number of type of possible motion applied to the robot will going to give us the degrees of freedom, and based on that it is classified. Third thing is based on the power source, that is electrical, pneumatic, hydraulic, whatever may be the power source is applicable to the robot, it is classified accordingly. And sometimes it is a combination of 1 or 2 or 3 is possible how to have a power source. Depending on the applications, we can select the power source. Third classification is based on path control or the trajectory of a robot. Trajectory is always with reference to the time of the travel of a robot from one place to another place. It can be point to point control, it can be via point control, or maybe the continuous path control. Based on that, it is classified. Next classification is based on the intelligence level. Say low technology or high technology, these two words are there. And exactly the meaning of that is if a robot can move autonomously in a space, it can be having a low level of technology. But if it can move along with the obstacle avoidance, it can have a little bit higher version. If it can move with obstacle avoidance, it can do the task desired, or it can take a decision also. At that time, it will be the higher version of technology. So likewise, it is classified. Certain other definitions are what should be the work envelope of it. A robot can reach up to some maximum distance into the space where the fixed base is there. So the distance at which the robot can reach as a maximum distance is as a part of work envelope in all the direction. Say next definition is payload. Payload is the highest load carrying capacity of a robot. Say, for example, my manipulator robot can hold up to 10 kg, maybe up to 12 kg, maybe up to 15 kg. So load carrying capacity is the most important criteria while designing a robot. Based on that, say self weight of the robot as well as the additional weight that the robot can carry, that will going to design the robot and its components. So payload is very important parameter in designing a robot. Say next thing is accuracy. Accuracy means if a point in a space is there and if the robot is approaching it for the first time, at that time, how accurately or precisely it can reach to that particular position. It is known as accuracy. Repeatability is very important for the robotics, as Gajjar sir has very well said that robot is utilized for the purpose where the task is very dangerous for the human being and it is of repetitive in nature. So repeatability of the robot is important, as the robot has to perform the task in repetitive nature. So say wherever a robot is trying to move at the place for the second time or the third time, what should be the accuracy at which it is reaching to that place? It is important parameter. Or consistency of robot is based on the repeatability parameter. So normally plus or minus 0.5 mm repeatability is allowed for the robotics for the precise task. So next definition is degrees of freedom. Before moving towards the classification of robot based on the manipulator, I need to explain the term degrees of freedom in detail. So degrees of freedom of a robot is very important to define robot dimensions and to have a particular application. So degrees of freedom is basically defined as number of independent coordinates required to specify motion for a particular robot or for a particular device. Say for example, if number of linkages, say robot is made up of number of linkages, right? So whatever maybe the linkages are there, say in the first diagram, left hand side, number of 4 linkages are there, A, D, C, and B. So these all the 4 linkages are joined together. It's a closed loop. Say in place of that, if there is one individual link, say for example, A and D, it is free to move in anywhere in the space. So at that time, I can say that my particular link can have 3 rotation along X, Y, Z axis. It can move with 3 rotation along X, Y, Z axis, alpha, beta, gamma, 3 angles. Similarly, it can have a possibility to move along X, Y, Z in a linear direction. It can move delta X, it can move delta Y, and it can move delta Z also. So likewise, a free link in a space has 6 degrees of freedom. But if you join 2 links together, definitely the degrees of freedom will compromise. So here in the first figure, I joined 4 links together and its degrees of freedom are only, say AD link can move angle theta. The theta is the displacement, only one parameter. So degrees of freedom compromises and left out degrees of freedom for this is becoming a 1. A very famous side crank mechanism we have heard of or you have seen it. In that also, the 4 links joined together will going to give the degrees of freedom as 1 only. But in robotics, depending on the applications, 1 degree of freedom is not sufficient. Say in the last diagram on the right hand side, it's a double pendulum diagram. Here the linkages are not in a closed loop. The another link is free to move anywhere. So if I impart that 2 links are there together, say link number 1 moves delta theta, that is theta 1, and link number 2 also can move delta theta or delta theta 2. So theta 1 and theta 2, 2 degrees of freedom imparted to this particular double pendulum. Of course, it is a 2-dimensional space, 2D mechanism. So 2 degrees of freedom are there over here. In the case of robotics, degrees of freedom are related to the mobility of a robot. Say if I want to move my robot to X direction, I need to give 1 degree of freedom to that. If I want to move it to the Y direction, then the 2nd degree. And if I want to rotate it, then the 3rd degree I need to apply. Normally, robots have 6 degrees of freedom, 3 for positioning and 3 for orientation. Say robotic arm resembling a human hand. Human hand should have minimum 6 degrees of freedom. Say starting from the shoulder joint, elbow joint, and the wrist joint. These 3 joints are used to position. That means if an object is there, if I want to grasp it, I need to move my hand towards the object, right? So that 1, 2, and 3 degrees are used to position an object. Then if I want to grasp it, I need to hold it or I need to grip it. At that time, another 3 degrees are required. That is the orientation. So 3 parameters for positioning and 3 parameters for orientation I need. So minimum 6 degrees of freedom for a robot is required. So degrees of freedom of a robot is directly related to the mobility, and depending on the applications, we can go for adding or reducing the degrees of freedom. If my task is possible with the help of 3 to 4 degrees of freedom, I can utilize that, because for the robot, each degree of freedom will going to add 1 actuator. I need to put motor to run my particular motion. Say if I want to rotate something, 1 rotation motor I need to put. If I want to have a transitory motion, I need to go for 1 linear actuator to have in my system. So degrees of freedom has directly equal to the number of actuators. So one thing is very clear or obvious for the robotics is that number of degrees of freedom is equal to number of actuators required for the manufacturing of a robot or development of a robot. So now I will show you the exact meaning of degrees of freedom. So here in this case, if I am saying that my displacement parameter will going to decide my degree of freedom. Say if I say that my X is a displacement of a rope which is attached to a pulley. So if X is my displacement and because of X pull applied to the system, my pulley will going to displace by theta angle. So theta and X are 2 different displacement parameters in this system. So if I say that if my X is a different parameter, theta is different parameter, it should give me 2 degrees of freedom system. But it's not like that. If I convert X in the form of theta or theta in the form of X, I can say that this could be having 1 degree of freedom only. So if I see the system, my X is equal to R theta, definitely it is seen from the picture itself. So this again, the parameters are 2, X and theta, but my degrees of freedom is 1. Similar example I have taken for the 2 pulleys example, where the 2 pulleys having different dimension, different diameter. So here also I can say that my X displacement is smaller into theta and Y displacement is 2R into theta. So X is equal to R theta. So theta is equal to X by R and Y is equal to 2R into theta. So if I put the value of theta from the first equation, my Y will become 2X. So here my X and Y both are interconvertible. That means I can write my Y in the form of X or X in the form of Y. So here my degrees of freedom is again 1. In the third diagram, in the right hand side diagram, I can say that my X1 is a displacement which is attached to mass M1 and X2 is a displacement which is attached to mass M2, and there is intermediate K2 spring and first spring is K1. So wherever I want to have displacement X2 theta, if I want to calculate it, I can write X2 in the form of X1. No, X1 and X2 both are independent now, because X1 cannot be written in the form of X2 or X2 cannot be written in the form of X1. That means I cannot have relation between X1 and X2. So here the degrees of freedom is added. Degrees of freedom in this case is 2. So likewise in the robotics also, we can apply this fundamental of degrees of freedom, and based on that we can have our desired motion for the application purpose. So few examples of degrees of freedom of our robots are, say first left hand side diagram is a sprinkler robot which is of 3 degrees of freedom. Here in this case black dot or black big dot is a first motor which is going to oscillate the first arm. second motor is there at the center level, and the third motor is there at the sprinkler level. So 3 degrees of freedom sprinkler is supposed to serve the purpose for these applications. Here I no need to grasp anything. So another 3 orientation parameters are not required in this situation. So that's why only 3 degrees of freedom is there. The right hand side yellow color arm, yellow color robotic arm, which is utilized for the purpose of pick and place. So here, say rotation of the base, yellow color base, and then silver color motor is there for the first link. Another silver color, the next silver color, and the last silver color motor is there for the gripping, opening and closing of the gripper. So 1, 2, 3, 4, and 5. 5 degrees of freedom arm is utilized for having picking and placing operations for a particular block. Right? So degrees of freedom is equal to number of actuators every time in all cases of the robot. Here is the right hand side corner is showing you the next say 6 degrees of freedom UR10 robot, which is available in our laboratory. It is a collaborative robot, and the collaborative robot or the safety features means a robot is having an application to hold something in his gripper or in its gripper. Say for example, it is intended to have to carry a load of 2 kg or 3 kg. So I have prepared a program to carry that much load into the gripper. But something is come into the picture, maybe some obstacle is there, maybe the human hand is there. If it is having load other than that 2.5 or 3 kg, it will stop working. Right? So it is a collaborative feature, or we can say that a safety feature, or we can say that it will not going to violate any laws of robotics, first, second, and third law. So likewise, these features, this type of features will be available in all the types of robots in the market right now, are in the say in the working space or maybe in the industry. So 6 degrees of freedom, if we want to count over here, is say the base is having a rotation, then the rotation of the link number 1, then number 2, link number 1 is a base, link number 2, 3, 4, 5, and 6. 4, 5, and 6 are the 3 degrees of freedom for the orientation of end effector. So another parameter, or we can say that the orientation parameter, that is 3 degrees of freedom or 3 rotation of a wrist, which is explained in this particular aeroplane diagram in a very well manner. So yellow color line, the green color line is the rotation, say rotation of a particular wrist about x-axis, we can say it is with the green color. U-axis will be the yellow, will be the blue color axis. Blue color is showing that the robot can have the motion, which is U-type, and the red color will be the pitch axis. Pitch will be the open and close motion. Say here in the left hand side bottom corner diagram is opening of the gripper is a pitch movement, then rotation will be the roll movement, and yaw will be the last movement, third movement. So that 3 movement is replicated based on the theoretical fundamental for the robotics. Say other than 2, 3, 4, 5, 6 degrees of freedom, there are robots available in the market with the multiple degrees of freedom. Say first left hand side corner diagram. Corner video is showing that it is a Navo robot. It's a complete humanoid, smaller version robot. In that 25 degrees of freedom is there. The hand of the robot has 3 plus 3, 6 degrees of freedom, and all other body parts has all number of degrees of freedom, and it can walk easily. It can even dance and perform so many tasks that human being can perform. The second video is showing that assembly robot, each in hand is having more than 4 degrees of freedom, can perform the task like a human being. So multiple degrees of freedom example is there in this. Dog robot by the Boston Dynamics, the third diagram in the right hand side corner. Say the yellow colored dog, which is moving the legs. Each leg is having 2 motors. So 2 degrees of freedom legs are there. So total degrees of freedom of a robot are 8. And the bottom one is a spider robot, which has 8 legs. 8 legs, and in these all 8 legs, each leg is having 3 motors, 3 degrees of freedom. It can move the leg with 3 different mobility, X, Y, Z, or we can say that alpha, beta, gamma, 3 angles are there. So total degrees of freedom in this case are 24, and the higher version of that particular robot will be there in the right hand side picture, spider robot. In even we can apply certain level of intelligence and camera vision system, or we can say that image processor system, and we can perform the tasks like surveillance and inspection with the help of robot. Say up to this point, we have seen that robot can have certain degrees of freedom based on the requirement, and we have just considered that the number of degrees of freedom is equal to number of actuators, and each joint must have uh, some uh, some actuator required to operate that particular joint. So now I'll start with the basics of joint, how robotics joints are classified. So basically there are two types of joints used in robotics. One is for rotation motion and another is for prismatic motion or a linear motion. So rotating joint or a revolute joint is a joint where the two links are joined with a pin connection as seen in the left hand side diagram. In the left hand side diagram, whatever maybe the two joints are there, each link is having a hole and the pin is inserted into the hole and then connection is tightened. And it is allowed to move freely in any direction in a rotation one. So I can say that 1 theta is a degrees of freedom for this particular set. Another second diagram is showing the another say combination for a rotary joint. Say 1 degree of freedom based on the axis of rotation, a robot can have a motion. And the third diagram is showing that there is a circular hole and a circular pipe is there, which is rotating inside. Say one important thing over here I want to mention is, say there is a collar over here. The collar is maintained over here to have a restriction of a motion of a particular pipe to move up and down in the circular hole. So if this collar is not there, the degrees of freedom will be violated. It can have a rotation as well as it can have linear motion also. So the collar is very important parameter over here. I need to mention that because if I want to have the degrees of freedom for a revolute joint as 1, it is to be tightened or fixed to have confined motion, which is desired. So this thing is important while designing a robot. We need to keep degree of freedom of each joint as 1. Second type of joint is a linear joint or a sliding pair joint, or we can say that it is intended for a parallel motion. So square hole and a square box inside that it is moving to and fro. It is a base example of a prismatic pair or a sliding pair. We need to apply linear actuator for this motion. But if it is a circular hole and a circular peg is there, at that time, this feature will be violated because it can have a rotation also. If a circular hole is there and a circular component is there, it can have a rotation as well as slider. So that is not allowed. With the help of one actuator, we can have only one type of motion. In this particular situation, it's a linear motion. So after understanding the basic types of joint, we can classify robot as a rectangular robot, cylindrical robot, spherical robot, jointed arm robot, and a SCARA robot. Say actually whatever may be the rotation or a revolute joint is there. In robotics, it is indicated as a capital R joint, and prismatic joint is there. It is indicated as capital P joint. So normally robots are classified as R joint, P joint. Double R joint means two revolute joints are there. Double P means 2 prismatic joints are there. And if it is triple R, triple P, it is 3 revolute joint, 3 prismatic joint. But sometimes it may be the combination of R and P both. RRP, RPR are the combinations. So we'll just take one by one each combinations. Say first combination over here in this video or in this diagram is a triple P robot. So all the 3 pairs or all the 3 joints of a robot which are of prismatic in nature. Say robot can move in a vertical Z direction, up and down, prismatic pair. It can move to and fro, prismatic pair. It can move in the Z direction, X direction and Y direction, to and fro. It is a third motion. So we can say that X, Y and theta are the 3 motions. And if we just take the extremities in all the directions, if we take extremity, it is going to give us the work envelope as a rectangle one. Say each corner of maximum reach or possibility of all coordinates will going to give rectangular workspace. So workspace of a triple P robot is, we can say that it is a rectangular one, and in many types in the industries for material handling, this type of robots are used. It can use for pick and place applications. Sometimes if it is a long welding path, it can be done with the help of this type of parallel robots. So the specifications of parallel robots are the 3 degrees of freedom, all are rectangular of a prismatic one. Rectangular workspace is there. Applications are welding and pick and place. The advantages are very large workspace or very large work envelope is there. So we can utilize anywhere in the industry at a long distances also. It is very simple to control because only linear pairs are there. Always compared to rotation motion, linear motion is easy to control. And it is having higher rigidity, accuracy, repeatability, and higher payload carrying capacity. So these are the advantages of it. And one limitation, only one limitation I can say. Otherwise, all can be manageable. So one limitation is it is taking very high space. So sometimes where there is a space constraint, we cannot go for utilizing such type of robot. And say at a time I can go for moving only X, only Y, only Z. All the three simultaneous motion is not possible in the case of prismatic pair. So that's why these two are the limitations. Otherwise, it's rigidity wise and industrial application wise, it's all good for the triple P robot. Next configuration in the series is double RP configuration. Double RP configuration is resulting into the cylindrical sort of workspace. So cylindrical workspace is having a advantage that it can reach up to the higher distance in a workspace. So that's why this sort of robots are preferable in the industrial applications. Say the base joint in the video is having a rotation. Another is whatever may be the linear motion along x-axis, and another linear motion is along the y-axis. So this is RPP robot, which is going to result into the cylindrical motion. Say ABB industry, Fanuc industries, they are manufacturing these robots for the industrial applications, and the payload capacity and all are desired based on the material that has to be handled. So specification of these configurations are say RPP joint is there, work envelope is cylindrical one. It has much more applications compared to triple P. It can use for the assembly purpose, for the pallet transfer purpose, inspection molding purpose, investment casting purpose, and foundry applications for material transfer and handling. It has advantages that it has larger work envelope, and another thing is it is conserving the very less space or vertical structure is there. That's why it is easy to manage. And it is easy to accommodate within a smaller space in the industry. So these are the advantages. It can also able to carry the very high payloads and utilize for the purpose. But the thing is, very much sophisticated controls are required to control these particular robots. And another thing is, this is having not that rigidity compared to PPP. Less rigidity and accuracy repeatabilities are also not compatible with the triple P robot. So these are the disadvantages of it. Similar to cylindrical configurations, another configuration is double RP. Double RP robot is having a spherical workspace. Spherical workspace robots are most probably used in industry for very intricate shape of applications, like say manufacturing of internal circuits and manufacturing of mobile phones, and that integrated task. If you want to go for at that time, double RP robot. Say R joint is we can say that having accuracy in the motion much more, and it is not that easy to control. So for integrated shape, higher level of programming is required to have an application of this. Certain specifications for double RP robot is a spherical workspace. It is used for die casting, forging applications, glass handling, choices handling, then parts cleaning, and loading and unloading of the parts can be done with the help of SCARA robots. It has large work envelope. Of course, as it is a vertical structure, is conserving less space and utilized for smaller level of smaller space areas also. And far-reaching objects we can use this spherical arm robot. And large load carrying capacity for this robot is there. As the structure of a robot is robust, we can go for a higher load carrying capacity. But the limitation is same as the cylindrical robot. It's a lesser rigidity compared to triple P. Accuracy and repeatability is also less, and sophisticated control and programming is required. So another set in this is the most important configuration is a articulated arm. Articulated arm is anthropomorphic arm, like a humanoid arm, or we can say that it is having all the three R joints. So say the requirement of a motion, whatever if it is a curvature is there, or maybe some other motion or desired motion is there, at that time we can go for this type of motion. All the type of possible motions we can achieve with the help of triple R joint. So that is the big advantage of triple R joint arm. So triple R joint has all the 3 degrees of freedom are rotary, all the 3 actuators are rotary. So in this case, if we want to use it, we can say it is directly resembling the human arm. Say all the joints are waist joint, shoulder joint, and elbow joint are the 3 joints, and 3 orientation parameters. If I add, that will be the gripper added to the robotic arm. So it will be the complete set of humanoid, complete set of a manipulator robot if we can go for triple R robot, and it is used in almost all the applications in the industries. So majority of the robot manufacturing industries having a mastery of manufacturing these 6 degrees of freedom 6R robot, 6R maybe 3R robot. 3R is a robotic arm and 3R is a robotic gripper. So 3 plus 3, 6R robots are there available in the market, and almost even Tata Motors, Maruti, they are using robots that are of articulated arm type. And it has of course larger work envelope but cannot be predictable. The exact shape of the work envelope is not predictable, and it has excellent reach and quality of manufacturing part, so used widely at almost all the places. But the mathematics behind the rotary joint is difficult to understand and difficult to program. So complicated mathematics or kinematic parameters are there. Even it is difficult to program. Workspace is difficult to visualize, and smaller error at joint level will going to add up more, or going to amplify at the end effector level. Say if my accuracy in theta 1 variation is say 0.05 and theta 2 is also 0.05, it will be multiplied at the joint level. So finally, that will going to add up to the end effector level. So it's very difficult to control the motions at that time. So very high level of kinematic parameter understanding is required for this. SCARA is a selective compliance robot, assembly robotics arm. So as the name suggests, it is utilized for the assembly of a certain thing. So it has one more degree added, one more degree of freedom is added, triple RP, 3 rotary and 1 linear motion. So I can say that it is a triple R arm added a prismatic 1 gripper, or we can say that prismatic 1 end effector. So it is going to use for certain purpose or certain applications. Say with the help of this, one can go for a spray printing application, one can go for pick and place application of a parts and assembling applications. So it has a very wide varieties of applications in industries. Say it can also be double RP or RPR arm in case of SCARA. It can be triple RP, 4 degrees of freedom or 3 degrees of freedom SCARA are available in the market, and its work envelope is like a donut. Donut shape, we can say that at a central level, it can reach up to the very high or very high far distances, and it can perform the task. It can perform the task for almost all the types of applications. And advantages are it has vertical structures taking less space, maximum outer radius is possible, faster cycle time, and excellent repeatability and good payload carrying capacity. Of course, this is limited to the planar space, that is 2D space. And there is one more, we can say that disadvantage is it can reach at a single point via two ways. So it is sometimes difficult to understand that the robot will follow what path. So 2 paths are that it has to decide one path and then move. So this could be the limitation, because if we are not intended that the robot will going to move to this path and it has used that, so that will be difficult to understand, and of course it is hard to program. So this particular diagram is going to show that the 6 degree of freedom complete robotic arm, and in that roll you and pitch 3 degrees of freedom of end effector is shown, and the 3 degrees of freedom of triple R robot is there. So this is a 6R robot which is having all the 6 rotary joints. 6 actuators are required for this. So 6R, 6 rotary joints, 6 motors are required, and it will going to perform the task for the 3 position parameters and 3 orientation parameters. So whatever may be the object grasping task is there, that is completely fruitful with the done fruitfully with the help of this type of robot. The basic components of a robot are like manipulator, power supply unit, end effector, and a controller. So if we take the analogy with the human hand, whatever may be our bone structure is there, skeleton structure of a human hand is there, that we can say that it is a manipulator. Whatever may be the human wrist is there, that could be the end effector which can going to grasp something. Power supply is there with the help of muscles of a human. Whatever our bone structure is there, that is covered with the help of muscle structure. So muscle structure is like a power supply. Controller, whatever may be the movement of our hand is there, it is completely controlled by brain. So controller is like a brain of a robot. So this is a basic standard analogy of a human hand and a robotic arm. Now I'll going to start with the certain basic drive components utilized for the robot. Say drives are very important parameters for the robot that will going to give you the motion. So sometimes it may happen that if we want to convert rotary motion into the linear motion, or maybe linear motion into the rotary motion, that is quite possible with the help of certain devices. Say rack and pinion is a very, very well-known device. We can know that it can going to convert our rotary motion into the linear motion. But sometimes more we can say that economic option is available other than rack and pinion is cam and follower mechanism. Cam and follower mechanism will going to convert our linear motion into rotary or vice versa. And similar to that, linear motion to rotary motion conversion, rotary to linear motion conversion is there with the help of slider crank mechanism. So these are the options we can say that less costlier than the gear drive. Of course, all the actuators are having a reduction gear, which is of worm and worm wheel type. So right hand side diagram is showing that the worm and worm wheel for very high reduction ratio. That means if a speed is 2440 and if I want to convert to the very low speed, at that time I can go for worm and worm wheel type of drive. Of course, power transmission from one wheel to another wheel can be done with the help of so many devices like a axle or maybe a belt drive or maybe a chain drive or maybe a rope drive. So mechanical drives are very, very useful in order to design a robot, because they may going to give us a economic design, as well as it will going to reduce our cycle time. It may going to give us the leverage advantage also. The bottommost diagram is going to give us the idea that how leverage principle is utilized for the robotic application. Say robot is a manipulator robot or maybe any type of robot is supposed to perform a task by a hanging mode. Your robotic arm has to extend to some extent and it has to take something or it has to grasp something. So leverage principle here is very much important to utilize for robotic design. So these are the basic principles or drives which we can say that we can utilize for our robot development purpose or a design of a robot purpose. Here in this particular we can say that simulations, I can show you the same type of motion with the help of two different robot designs. Say first robot design over here, which is of 2-point contact design, which utilizes rack and pinion design to have a climbing motion on a ladder. So of course, ladder climbing robot design is a bit difficult one because it has to travel in a vertical structure opposite to the gravity direction. So dynamic stability is also important here. So first diagram is there in which we have taken rack and pinion robot, and in that two clamps are there that are opening and closing, and the rack will going to travel in the upward direction and the robot is climbing the ladder, right? So here whatever may be the number of actuators required are there. That is, first one is to run my pinion. Pinion has to rotate. So one revolute joint is required for that. Another is 4 clamps are supposed to open and close. So 4 different motors or servo motors are required to just to have opening and closing of the 4 clamps. So here this climbing motion I can have with the help of 5 motors. So 5 degrees of freedom are there for this particular robot. If I take the second diagram, the middle diagram, in the middle diagram, the climbing motion is same as it has to climb a ladder. But in this case, we have taken a robot gripper and 2 linkages and a base of robot. The yellow one is a base and the 4 arms of a robot like a quadruped. So 4 arms are there. Each arm is having 3 degrees of freedom. It can have one motor is attached to the base, one motor is attached to the blue and green color link, and third motor is attached to the red color gripper, right? So 3 motors for 1 leg and total 4 legs are there. So I need to have 12 motors totally to have this particular motion with the help of this design robot. So just the design changes, thus the mechanism changes, my number of motor is increased from 5 to 12. So it is there in the hand of designer that what type of mechanism I need to choose for my application. Say here, the thing is the 2-point contact design is there. The first one, 2-point contact design is having a very fast cycle time compared to 3-point design. The second one is a 3-point design. At a time, only 1 leg is operated. All other 3 are there in the support. So in this situation, we can say that even with the help of lesser actuators and with the help of lesser number of components, we can have a same motion with a fast timing or with a higher cycle time. So it is there on depends on the mechanical designer that what type of mechanism he want to choose for his application. Say for certain heavy duty applications for a stair climbing or a ladder climbing, the next design right hand side design is showing that there are 6 grippers. All are pneumatically actuated. So 4 cylinders are there that will going to actuate 6 particular grippers to climb a robot on a ladder. And here the total number of grippers are 6. Similar type of pipe climbing arrangement is there in the bottom design. Say 3 revolute joints are there and a gripper is actuated with the help of a lead screw. So this lead screw design of 3R robot will going to serve as the same as the upper one design. The upper one is a heavy structure with a costly pneumatic cylinder designs, and the bottom one is having triple R joint and only lead screw to open and close the gripper. So likewise, it is there, of course, in the head of the designer that what type of devices or what type of component he or she has to choose. So these are the certain basic type of components, or we can say that the project developed in our laboratory. The students have developed these all particular robots with the help of aluminum sections, plastic material, the gripper, see the bottom gripper for the frictions, they have used the tennis ball, and each joint has one motor. So the quadruped robot with the crab motion design and simple motion design, the two projects are there. The next one is a ladder climbing robot, the rack and pinion design. Whatever I have shown the simulation, the same was developed over here in our laboratory. Certain robotic components or parts are made up with the 3D printing. Certain ready-made, whatever maybe the wheels students have used. Certain plastic material, maybe the foam material, aluminum section. This is a hoarding design. Whatever is the opening and closing or up and down motion is there. Stair climber or decline of the stair will be there with the help of this. So these are the projects developed in our laboratory for the basic purpose, and will going to give us the idea of components and materials to be used for the robot. Say next is the number of types of grippers used for the robotic applications. Say here the robotic grippers, whatever I have shown is having only opening and closing motion right now shown in the videos. Say, but depending on the material to be handled, the coating of or a layer of a material is there on the strips of gripper is required to be done in order to preserve the identity of a particular component. If it is a polished part, I need to have a material which is a smoother one in nature that cannot damage the surface finish of a part, surface finish of a component. Similar to that, as the shape of the component, if it is a circular one, then the second type of gripper is utilized. For opening and closing, this type of the third, the silver color grippers are there, which is having a gear for opening and closing that are to be utilized. Say these grippers are having only one motion, that is opening and closing motion is shown over here. It is attached to another device like that in the right hand side last diagram. Say whatever maybe the gripper is there, that is attached to the manipulator arm, which can roll and which can have a roll and yaw motion also. It can have motion in the Y and Z direction, and X will be the opening and closing direction. So this three motions together or three motion simultaneously will going to help to grasp something with the help of robotic gripper. Say these are the mechanical grippers which are made up of the hard material. Certain grippers are there available in the market, or maybe people can design and develop of their own, which are made up of soft material to handle the delicate things. Say like a fruit handling, say apple pruning and the grape pruning, maybe tomato pruning. Robotic arms are readily available in the market, and that are utilizing silicone grippers just not to damage the fruit. Similar to handle a glass, another type of gripper is there. See, application of a robot can be any, and based on the applications, you can design your robot or robotic gripper, maybe soft or a hard. And material chosen can be also depending on maybe carbon fiber we can use, maybe a silicone material we can use, maybe a plastic. Say another aspect for mechanical engineering design is, say my joints and links have certain limitations. Say whenever I join two links together, they cannot have a rotation of 360 degree or 180 degree. Say if we take an example of our human hand, we cannot rotate it up to 360 degree. Even the roll and yaw motion is also having certain limitations. Up to 45 degree, I can go for the pitch motion. Say here it has shown in the video that my robot cannot move inside the another part in a space. But if it is a 3D space, I can move it here and there, back or front in the front of the another component. So that motion is possible. So certain limitations of mechanical joints are there that will going to consider while designing a robot motion. Similar to that, the robot end effector, or we can say that yaw motion, has certain limitations, which is seen directly from the video that it cannot move beyond 45 degree. and we beyond 45 degrees in both the directions. So beyond that, it cannot grasp any object or not going to perform the application oriented task. Certain limitations are based on the speed of actuators. Say certain reductions of the speed, certain increment of the speed or speed limits or accelerations cannot be achievable, whatever are desired for the applications with the help of mechanical components. So that should be taken care while designing the application. And certain safety applications, we can say that there must be the emergency stop where anything comes into the obstacle. That means which is other than the robotic applications. Your robot can stop, emergency stop. E-stop button will be there for each robot. Sometimes there are fencing, or maybe we can say that it is a laser light scanning or a curtains are provided to just safeguard the any other obstacle or maybe the human being into the path of operations of a robot. Say varieties of components which we can utilize for the robotic applications, that will have an idea with the help of this sort of pictures. Even we can go for utilizing a wooden material or wooden wheel to have robot applications. A number of wheels available in the market are of varieties of type. There are simple differential drive wheels, then Ackermann steering gear drive wheels are there, Omni drive wheels are there. Omni drive wheels can move even a sharp turn in X, Y, or Z directions. So that are very good ways to have a robot motion. Legged mechanisms are there, legged rovers are there. Even we can utilize a track like a military tank for the motion of a robot for certain applications. Say these tracked motions are very useful to have climbing, or very we can say that all type of terrains we can go for this particular track type of motion, track type of wheels. Say another manufacturers of robot can have, say ABB robot has 6 degrees of freedom application robot. Asimo is a pure humanoid robot, which is a human service robot. HRP humanoid robot platform, HRP 4C, HRP 2C, HRP 3C. There are a number of humanoid robots HRP type are there, which can perform the task resembling the human applications. Certain robots which are used for floor cleaning purposes. Mars rovers, all of us are knowing that very well. It has last up to more than 1 or 2 years and perform the task of inspection and giving us lots of information about the Mars. Certain predator robots, or we can say that drone type of structure, or we can say that helicopter type of structures, which we can use for the surveillance purposes. Medical robots are also there, and certain say entertainment robot like a dog robot are available in the market. Say other than this, we can have a robot design. Say certain robot designs people have made, like a dancing robot, and a drone is there. Floor cleaning robot, and along with that, manipulator arm is mounted on it. On the left hand side, second figure. Say in this situation, what happens if a big object is there in the path of a floor cleaning robot? It will grasp it and then put it somewhere, put it at some different place, so that floor cleaning robot can serve the purpose of whatever it has to be done. Certain vacuum killers which are of autonomous in nature are coming into the classification of robots. So these are the varieties of mechanical components which are used for the robots. And nowadays with the advanced manufacturing technology, the manufacturing of any sort of shape you think that can be manufactured with the help of 3D printing, maybe additive manufacturing, printing any material you can go for using for the robot purpose. Say as you think of it, and you can have a development of that particular part, that type of technology is available. So shape, dimensions, design, whatever is desired for the applications, we can develop it. So that is the main beauty of the modern technology of manufacturing, and it can club with the robotics to have the purpose whatever we wanted to go for the applications. So these are certain standard basic platforms available in the market for the mobile robot. So mobile robots are having a base platform which is going to move, and upon that certain applications are mounted, like a manipulator robot is there, or maybe a surveillance camera is there, or maybe image processing is there. So image processing system is there. So mobile robot base are of 2-wheel type, maybe 4-wheel type, omni wheel drive, or maybe motion transmission on the wheels will be based on the, say, chain or a rope drive. So these are the basic types of basic 4 types of mobile robot base which are available in the market. And these are the mechanical components I have covered so far. And my colleague Dr. Akash will going to give us the idea of electronic components which are to be used for manufacturing and development of a robot. Next is Next is a selection criteria for a robot. What type of parameters we need to think or we need to take care while selecting a robot for our applications. Say first of all, based on the applications, we need to go for a type of drives, whether the robot I need to select is for servo drive or non-servo drive, based on the desired application, that is work envelope, up to what distance it has to move, up to what type of task it has to perform. So second criteria we need to take care is of work envelope. Next one is payload capacity, how much load a robot has to carry. Third one is cycle time. It has to perform a certain application or a certain task within a prescribed time. So based on that, we can select our robot. Repeatability, drive selection, and unique capability. So these are the points to be taken care in the mind while selecting a robot which are of the technical side. Non-technical parameters are, of course, the first one is the cost. Cost and safety are two contradictory parameters. If you want to go for a safety, or in any case, safety will be there on the top priority. Say if cost is less and safety is not there, people will not going to buy it. So safety will be there on the top priority. And second one is this cost, I can say. Next one is a commonality. If I want to purchase or if I want to select a robot for certain applications, what are other applications I can perform with the help of that? So if commonality is high, I can go for that particular design so that I can have number of applications based on that. Say normal industries are thinking on the part that the people are required to be trained for the utilization of the robot and for doing certain tasks with the help of robot. So the training cost and maintenance cost of the robot is one of the parameter for the selecting the robot. Repeatability, depending on the application, if it is a precise application, repeatability is much more high, and repeatability is again going to add up to the cost. So this is a parameter which we can think of. Services and the system help. Say support system is most important in this particular robot selections. Say whether the support system is poor, we are not supposed to buy for that particular. We are not supposed to select for that particular type of company or a robot. And services are of the same importance. So these are the parameters which we need to take care while selecting the robots. This is all over for the mechanical components from my side. If anybody is having any questions. Yeah, there is a question like, is there any certification or a standard needs to be followed to use the robots in field? Yeah, of course. We need to say even if I make a drone, I cannot fly that in the air directly. Police will come. So there should be the standards and certifications required to even utilize a robot for the purposes. So there should be the safety features first. There should be certain criteria to use that. Certain space requirements are there. So certification is required, of course. Next one is what would be the maximum degrees of freedom which can be made possible or allowed for a mobile robot? Say for any sort of application, degrees of freedom is not a fix. Degrees of freedom is always a jugglery of a designer. Say as I going to add a degree of freedom, it will going to add to my actuator cost. Even I can go for 50 degrees of freedom, I can go for 200 degrees of freedom, and maybe 500 degrees of freedom. Depending on the application, degrees of freedom choosing is a designer's, it's there in designer's hand. But of course, designer always try to have a lesser number of degrees of freedom because of the actuator cost. So it depends based on the applications. Mobile robot can have even 200 degrees of freedom possible. Servo and non-servo type, can you please elaborate more on this? Yes, of course. Say whatever maybe the servo drives are there, based on that we need to go for a servo motor. Servo motors are we can say that non-DC motors, and DC motors are costly one compared to servo motors. Even small servo motors is available within 200, 300 degree cost, and DC motors are of course having a higher cost, maybe 1000, maybe 2000, depending on the capacity. So non-servo drives are preferable for the toy sort of robots, and servo drives are preferable for the more controls required. So these are the things for the servo and non-servo drives. Could we use robot as a software developer? if we impart that much intelligence to the robot, then it is possible. Otherwise, it's I don't think that a software development task can be done with the help of robot. Yeah, of course, certain basic module typing task is there that we can impart. Certain basic steps are there that is common for all that we can do with the help of robots. Otherwise, intelligence level, that level of intelligence we need to impart to the robot. That AI and ML tool we need to impart to the robot. How to select good BLDC motor? Say motor part, BLDC motor part that Akash sir will going to cover. I cannot say much more in that. It's not moving now. What is the certification necessary for robotic software? That is in aerospace, we follow D0178 standards. So this certification part will be covered by Dr. Gajjar in tomorrow's class. Seriously speaking, I am working on the climbing robots, and then these aerospace standards I am not knowing right now. I think it's closed. Yes, can you explain about mobile robots with let's say 6 legs? Like how many actuators are uh, actuators for n number of links? How many joints for each leg uh, with n links? Yes, of course, say if there is a mobile robot and if it is a legged one and each leg is actuating as per the gate planning situations applied to the robot, at that time, number of joints will be equal to the number of actuators required. But if it is a wheeled mobile robot, at that time, we can have drive applied to the 2 or 3 wheels, all other wheels are the followers. So in that situations, we can have lesser number of actuators. But in the case of legged robot, and if the leg planning for all the 6 robot or gate planning is different, at that time, number of joints is equal to degrees of freedom is equal to the motors or actuators required. Right? Is there any pursuit robot like drones, parachute robot available like drones? Yeah, there are lots of robots available. And if the load carrying capacity of a drone is much more higher, we can utilize parachute with that also. It is even drones starting from 4,000 rupees to 40,000 or 80,000 rupees available on Amazon also. So we can have a buying of DIY kit, do it yourself kit, and preparation of drone can be done at your place also. But of course, there is a problem with the flying of that drones into the field or maybe in the open air. So right now our radar systems are so much powerful that you are not allowed to fly any drone in your place without the permission of higher authorities. How to secure robot from hacking? I am a pure mechanical person. I don't know anything about hacking. As far as possible, I can say that whatever maybe the robot controls are there, you should not put that online. Otherwise, there may be definitely chance of hacking. Otherwise, keep yourself your whatever material is there that is with you and don't put it online. For accuracy, can we use stepper motor or servo motor? For accuracy, we can go for servo motor. What are the preferred RTOs used in robotics? RTO stands for RTOS. Real-time operating systems. Say Arduino operating system is there, ROS operating system is there. Whatever maybe the systems you want to go for, that you can prefer. It's over. Yeah, thank you very much from all the participants, and I want to like to thank to E-Info Chief, IESA Club, and Dr. Nagendra Gajjar to give me the opportunity to present this talk on the webinar. Thank you all very much.
Just a second. Okay, so good noon, everyone. I believe I am properly audible. So the last two sessions of the day would be on electronics part. The first session is key components of robotic system, electrical, electronic sensors. Okay, so let me make my pointer on so that. Okay, so these are the basic components of any robotic system. It has actuators, electric motors, pneumatics, sensors, piezoelectric motor, ultrasonic sensors, motors, then muscle wires, power supplies, and all. As far as electronics is concerned, we may basically see that actuators cannot be actuated without the electronic involved. Similarly, sensors have the part of electronics. Electric motor is also concerned with the electronics and power supplies. Other than all of this, one more thing which is very, very important, covered by Madam already, is the controlling boards. So controlling board is something without which you cannot control your actuators or sensors or motors. So there will be controlling boards which will be controlling entire robot. And between the controlling boards and all those stuffs, what we have seen in this particular figure, there is something called interface. Interface is very important part of electronics. So basically when a robotic systems is looked at, so people will say that it is a multidisciplinary task. So broadly we can distribute the robots in electronic part and mechanical part. Then in mechanical you can have a number of different components. Again in electronics there'll be a number of different components. So people from computers, people from electronics, or people from electrical, or maybe instrumentation can be a part of electronic part. In all the part, the interface is very important requirement. So we have three major components in robotics. One is the controlling board, one is the interfaces, and one is this part, other components where actuators, sensors, and motors and all will come into picture. So what we'll do is we'll divide them in three parts. First part would be the interfaces. We'll see what are the different interfaces available. Then we'll see what are the different controlling boards are available. And then we'll see the third part where we'll see actuators and sensors. At the end, I'll try to show you 3 or 4 small videos which will tell you how this all three are combined. So let us go with the first part, that is the interfaces. Okay, as far as the interfaces are concerned, first of all, there are two things. One is your interface could be serial or it could be parallel. Interface means you can say that it's a communication that happens between the microcontroller board and the sensors or actuator. So basically the way you communicate. So communication can happen in two ways. One is a parallel and one is a serial. So this particular figure shows the analog communication. Normally when we say analog communication, then we don't see parallel or serial. It's a normal analog communication where an analog signal is an input and it is passing through a specific filter so that the next circuit can easily handle it. Then there will be analog to digital conversion. And from analog to digital converter to microcontroller, there would be a serial or parallel communication can happen. What is shown here is a serial communication, only single line is there. So an analog signal is converted to digital signal and is given to the microcontroller. So to interface an analog signal to a microcontroller, we require something called analog to digital converter. Fortunately, all the modern microprocessors or microcontrollers, they are inbuilt to A to D converters available. If they are not available, then we have to interface an A to D converter that will take care of the analog input signal. Because see, all the real life signal, your sound, your video, or any signal that comes from the sensor is always analog in nature. And some sort of A to D converter is required. There are sensors available which will directly give us the digital output. Those sensors have the inbuilt A to D converters available. So in microcontroller, we have to interface these sensors. So this is serial. Serial means one by one all the bits will come. I believe that the audience have the background of bits and bytes. So byte means is a combination of 8 bit, and bit is a single bit at a time, which can have value of 0 or 1. Normally, when we talk in terms of microcontrollers cannot deal voltages less than 0 volt and cannot deal with the voltages more than 5 volts. So we can consider 5 volts, or in a modern processor 1.8 or 3.3 volts is considered as 1, and 0 volt is considered as 0. So when I say a serial communication, then it could be a 1 bit at a time, a higher voltage level or a lower voltage level, and that a microcontroller will take care of. And if we say the parallel communication, this is a kind of parallel communication where more than 1 bit is going to a microcontroller. Normally, the parallel communication is a very fast way of communicating between your inputs and microcontroller. The issue with this is, see, if your input and microcontroller are very close to each other, parallel communication can happen very easily. But if there is a distance, then each wire that we see here has a different delay, and we cannot control that wire delay. So here at the microcontroller end, you cannot guarantee that all the bits will come together. If they do not come together, then the synchronism is an issue. And if the distance is very large, then laying down so many wires parallelly will also give you the lot of cost and maintenance issues. So there is a serial and parallel communication, and analog and digital input signal. 2 ways are possible. Whatever happens, finally your microcontroller will deal with the digital signals only. So finally, we should make sure that microcontroller should take the digital signal only as the input. Okay, so other than serial and parallel communication, what we can have is a sophisticated protocols available. There are few protocols which are very common and very famous. So we'll be looking at those protocols. So the first and the foremost protocol, which is very famous and used very often, is called UART. UART stands for Universal Asynchronous Reception and Transmission. So there'll be 2 parties communicating. Every party will have 2 pins available. 1 pin is for transmission, 1 pin is for reception. So the reception pin of this party is directly connected to the transmitter pin of this party, and vice versa. The reception pin of this party is connected to the transmission pin of this party. Okay, and then there would be a specific way of communication. That is what we call protocol. Protocol is a set of rules that we are supposed to follow when we communicate between 2 devices. So how this will be followed? See, I am not given a much detail here, so that I'll try to make it as simple as possible. So what will happen is, there will be 8 bits of data. D0 to D7 are the 8 bits of data that I want to transfer from, let's say, UART1 to UART2. So that is 8 bit of data. Other than this 8 bit, I have one optional bit that is called parity bit. So this optional bit that user may define whether he wants to keep this bit or not. Okay, so what this bit will do? This bit will decide whether there is an error here or not. Let's say I say that this bit is even parity. Even parity means this D0 to D7, whatever bits are there, this bits can take value either 0 or 1. So when I say even parity, that means this number of ones, yahan se yahan tak whatever bits are there, those bits, total number of ones should be even. If they are not even, then I'll add an extra 1 bit here and make it even. So that is what terms as even parity. So when this data is received at UART2, UART2 will see that UART2 also knows that the data is done in even parity. So number of 1 should be even, considering this all 9 bits, D0 to D7 plus this PB bit. Similarly, you can also set the odd parity. So this is an optional bit. If the communication range, or you can say the distance between transmitter and receiver, is very small, in that case, you can omit this parity bit. No need to put it because there are very less chances of error. Then there will be a start bit and there is a stop bit. Start bit is always a, you can say a low bit. Stop bit is always a high bit. So this is a clock shown when this particular, you can say half a bit, will see the age of this. So when age is going from 1 to 0, it is considered as a start bit. And then when age goes from 0 to high, it is considered as a stop bit. Same way, D0 to PB, all will also go from 0 to or 1 to 0, but we'll try to look into the start bit and stop bit. Now, when we say UART, asynchronous communication, then this clock is not transmitted between transmitter and receiver. Transmitter and receiver work on the similar clock, but they are independent of each other. So there are few settings we need to do before the communication starts. And those settings means how many bits I am going to send in one such signal. This one such signal between start bit and stop bit is called a baud. So we have to say to the transmitter and receiver both how many bits are there in a single baud. Let's say I am going for 8 bit of data, D0 to D7, 1 bit of parity, a start bit and a stop bit, then total 11 bits would be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So there will be 11 bits per baud. I can omit the parity. In that case, there will be 10 bits per baud. There are options available that you need not to send all the 8 bits in data. You can go for 5 bits, you can go for 6 bit, 7 bit or 8 bit. 4 options are available. So again, your size of baud will change. So you have to tell to the transmitter and receiver both that how many bits are there in a baud. Then you have to tell whether the parity is there or not. And then you will also have to say that how many such bauds will be transmitted in 1 second, what we normally call baud rate. So this information we need to impart to both the communicating parties. So what will happen is whenever you try to code this kind of communication, these settings are to be done in both parties, transmitter and receiver, and this coding part would be similar in transmitter and receiver. If both are working on different bit rate or different baud rate, then your reception will not happen properly. It will show you an error. Okay, I'll tell you how the error will look like. So this is UART, Universal Asynchronous Reception and Transmission. This is one of the very famous protocol, and there are various sensors or various transducers, or you can say actuators, which are working on this protocol. I'll show you the example. What are the different sensors which work on this protocol? The disadvantage of this protocol is that only 2 parties can communicate with each other. Let's say I have 8 or 9 sensors which are working on UART. Then I require hardware UART available with my microcontroller, which is not easily available. There are few microcontrollers which can support 3 or 4 UARTs at a time. Otherwise, you'll have to go with PLC kind of logic where you can program as many UART as required. But when you add so many UARTs in your circuit, then other functionality will also be suffered. So that UART has a problem, one-to-one communication possible. So how to overcome this particular problem? So for that, we have the other famous communication protocol available that is called SPI, Serial Peripheral Interface. What SPI will do is SPI will allow multiple slaves together. So what will happen? This master normally would be my microcontroller, which is controlling the entire robot. And these all are either my slaves, or you can say different actuators or different sensors which support this SPI interface. So there'll be slave 1, slave 2, slave 3, and so on. So what are the different control between slave and master? So there'll be 4 controls. One is the clock. So this is, you can say, a synchronous communication. In UART, the clock was independent at master and slave, but here the clock is dependent. So master and slave will be working on the same clock, and the same clock needs to be transferred to all the slaves. So that is a synchronous communication. You can see this blue line shows that clock. Then there is an output called master out, slave in, or MOSI. So that master gives the command to the slave. So when master wants a signal from slave, it will give a command that send a signal and slave will send a signal. Then there is an input to master is called master in, slave out. So that is from slave to the master, this green line. So these 3 commands are common to all slaves and master. So there will be a 3 line which is connected in a broadcast mode to all the slaves. So there is a single master and n number of slaves possible. And then there is called slave select. So there is 3 separate lines for 3 slave. Slave select 1, slave select 2, and slave select 3. So now master can decide that which slave he wants to communicate. So master will select, let's say, slave number 2. So this particular line will go low, and this red line and blue line will go high. So these 2 slaves are not selected. Even if they send any data, master will not look at that data. So what will happen is slave 2 is selected. So this pin will go low and slave 2 is selected. And then the communication will happen between master and slave. So this way, by selecting a particular slave, we can communicate with n number of slaves. But as many slaves we want to communicate, that many slave select lines are required. So if you want to communicate with 100 sensors which works on SPI protocol, then you require 103 lines available. 3 lines for clock, MOSI and MISO, and 100 lines for slave select. So that is called serial peripheral interface. So here the problem of only 2 communicating party of UART is solved by having slave select pin. But again, the problem is you require separate slave select for all the slaves. So again, you require so many different pins available in the microcontroller. And this may create a problem with number of pins. So beyond this, we can have one more protocol that is called I2C, Inter-Integrated Circuit, I2C protocol. Nowadays, there are n number of sensors or transducers, or you can say actuators available which supports I2C protocol. So in I2C protocol, what will happen is there will be only 2 lines between master and slave. So there is a master and there are multiple slaves. 2 line is called SCL, that is serial clock, and SDA, that is serial data. S stands for serial, CL stands for clock, DA stands for data. So serial clock and serial data, all these slaves and master are connected with only 2 wire communication. There'll be only 2 wires. And what will happen? There is a separate address given to slaves. You can also have multiple master in this case, and every master will be given a separate address. So what will happen is master wants to talk to any other master, any other slave. They will just put their address and send data on this SDA. They are synchronized with this serial clock. So all these slaves and master will receive the same data, and whosoever will respond, only the person will respond whose address is written in this particular message. And the message will follow this particular kind of, you can say, pattern or protocol. This is again a serial protocol. So start bit will go first, then address frame will go first. If you are using a 7-bit of address, then you can have 2⁻⁷ different slaves. If you go with 10 bits of address, you can go with 1024 different slaves. Then there will be a read write bit, acknowledge bit, 8 bits of data, again acknowledge, 8 bits of data, again acknowledge, and then a stop bit. So you can send 2 8 bits of data in one go. And read and write means if master is trying to say something, it is called write bit. If master is trying to read something, it is called read bit. Read bit is normally low, write bit is normally high. So that is how the slave and master will communicate using this particular protocol. Now when it comes to coding, so if your sensors, if your actuator or your transducer support any of this UART or I2C or SPI, and your microcontroller also support the same protocol, your coding is extremely easy. You need not to do anything. What the IDEs you are using, or you can say the tools you are using, those tools will give you the support, and the separate hardware is available in your sensors and your controller. So you have to just activate that hardware, and all this frame format and everything will be taken care by your IDE. You can also explicitly code for this I2C or SPI. If I2C or SPI is not available, and if you want your sensors to work in that way, you need to integrate your own controller with your transducer that will take data from your sensors or transducer and convert them into I2C protocol, and that I2C will talk to your controller. That kind of arrangement can be made. But as I have said, these are very popular, you can say, protocol, and those protocols are now supported by all modern sensors and transducers. So these are common UART, SPI, and I2C. Other than this, there are others also which we have heard of. HDMI is there, VGA is there, then your LAN connector, RJ45 is there. Then there is, you can say, USB protocol is also there, and PCI Express is also there. But these all are more sophisticated, and normally to deal with this protocol, you require an operating system on your controller. So normally if your controller does not have an operating system, then UART, SPI, or you can say the I2C protocol, or you can say simple analog digital parallel communication can be supported. But if you are using this kind of protocols, HDMI or USB or PCI Express, then you require an RTOS and you require a specific kind of coding to support this kind of interfaces. These interfaces are also very famous, specifically when you are dealing with a display device, when you are dealing with human machine interface, when you are dealing with transfer of video data between your robot and other environment, then this kind of data is required. LAN is normally required when you want to upload your data to cloud and so on. If you are making a simple machine which is not communicating with the external world other than sensors and transducers, then this kind of protocols may not require, and then you can get rid of your operating system. Without operating system also, you can operate your machine. So this is all about the interfaces. Then the microcontroller board, our second part. So microcontroller, normally we call it single board computers. So there could be a single board computer or there cannot be a single board computers. So when I say single board computers, there are n number of single board computers available. Let us have a look at them. I won't go in much detail. I'll just show you the series available. Arduino is something which is very powerful and very famous now because it is extremely easy to use. So any beginner can easily go with Arduino. The IDE of Arduino is freely available on the net. You can just download, plug and play with your Arduino board. Very cheap and very easily available. It is open source. So once your circuit is done on Arduino, you can transfer your circuit to your general purpose board also, or you can make your customized board also. So these are the various series. Arduino Uno is very famous, easily available. The higher board of that is Arduino Mega board. Arduino Leonardo and Arduino Uno are similar kind of board with different interfaces available. Then Arduino Uno Mini is available, Arduino Duo board, Micro board, Zero board. All this board, as a beginner, you need not to look into the hardware of this. You can pick any of this board depending on your requirement, or maybe you can say number of pins you want, or you can say what kind of interfaces you have, or you can say easily, you can say that how many pins you require at the output. Depending on that, you can choose any of this board. The IDE will remain same. So as a user, if you are very new to the robotics field, you need not to get into the hardware of this board. You can pick any board depending on how many input output you require, and you can directly go with it. So these are the Arduino series. There are other shields available which can be interfaced with Arduino. So these are also some of the boards like Nano board, Arduino Nano IoT board, Arduino Nano RP2040 board. Similarly, as I have said, again, you need not to get into the what hardware or what microprocessor it is using. You can select what kind of application you want to develop, what is the size available, how many pins available, and you can directly select if you are a beginner. Then again, there are other shields are also available. So if you want to incorporate the Wi-Fi facility in your existing Arduino board, you can go with this kind of boards. So these are the various shields available for Arduino boards. Then if you don't want to go for shield and Arduino board, you can directly go for the Arduino board which are available with Wi-Fi facilities. The first board you can see here in this series is ESP8266. So this ESP8266 has the processor itself. It has the antenna connectivity and directly connected to the Wi-Fi. So this board is a programmable board which has many input output pins. It also has the analog and digital communication pins available. It also supports UART, it supports SPI, it supports I2C. All the three protocol it supports. So you can connect any of your sensors or transducer directly with this, and you can program it. Directly it can be connected to Wi-Fi. So if you have the Wi-Fi available, this board can directly connect to Wi-Fi, and sophisticated programming skills are also not required. It's an open source board. A lot of forums are available. You can directly go to the forum and you can go with the code. Even if you download the libraries of this in Arduino IDE, n number of examples are directly available. So if you are a beginner, go to examples, open that example, and you can directly use it without having much knowledge of this board. The higher version of this board is ESP32 board, which has Bluetooth and Wi-Fi. Both the functionalities available, and more number of digital pins are available. Then this board is ESP32 camera module. This board is less than 100 rupees board available in the market. So what you can do is you can directly connect your camera into Wi-Fi, and the camera quality is terrific. This board also gives you almost 1000 image it can store. It is inbuilt with the image recognition and all. You can directly program with the Arduino IDE. As I have said, less than 1000 rupee board. So if you want to develop your surveillance system in your robot, you can easily use this board. Again, this is compatible with Arduino IDE environment. If you buy this kind of board, the coding for this board is directly provided by the developer themselves. So you can easily code them. These are the two, this is same board, front end and back end. This is called HC0506 kind of board, specifically designed for Bluetooth. So if you want to design any automation system where Bluetooth is involved, your Arduino can directly be connected to this board, and this will provide you the Bluetooth interface. So this is the Bluetooth antenna available, 2.4 gigahertz it will work with. And these are the normal interface. VCC require, ground require, other enable require, and TX and RX pin. So this is directly connected to the UART of your Arduino, and then you can directly use it. So transmitter receiver can be designed. These are the other wireless board. Then if you want to go for the sophisticated computings, like image processing is involved, or you want to design the robotics that can work with AI and ML kind of interfaces, you require to interface the USBs, keyboard, you want to interface mouse, then HMI, then Arduino may not be that sufficient. Then you require the higher boards. So Raspberry Pi is the next version of famous board. These are the different version of Raspberry Pi. So this is Raspberry Pi 3A plus, 3B plus. This is the modern Raspberry Pi Zero board with some less functionalities. This is 3B board. Again, if you are a beginner as a user, you need not to get into the architecture of all this board. But yes, if you are doing some sophisticated programming, then you must get into the architecture of it. In the next slides, I'll cover what are the differences into this. So these are the Raspberry Pi board. So you need to install the OS. So that is also very easy. It's again, you can say kind of open source stuff. All the boards have a functionality to interface a micro SD card. So what you can do is you can go to internet, you can download the Raspbian OS, which is a Linux version, which is compact Linux version, which is customized for this kind of board that can be stored into your micro SD card. You put the micro SD card in the board, and then when you boot up this board, it will take the OS from that card itself. And then your coding and everything will get into that particular card. So if you download this kind of operating systems, they are inbuilt with USB interface, keyboard interface, then your audio video interface, everything is available. Then once the OS is loaded, this board can work as a mini computer. That is why we call it a single board computers. So these are some of the Raspberry Pi boards available, 3A, 3B, 0 and Raspberry 3B. What is the difference? You can see the SoC type. SoC type, the different Broadcom SoCs are available on those board. Then the core type, this is Cortex A53, Cortex A53, the different ARM Cortex. Then number of cores available, 4 cores, and this is 1 core. As I have said, this is less sophisticated board for a small application, so only single core. And again, 4 cores are available. You can see the CPU clock, 1.4 gigahertz, 1.4 gigahertz, and 1.2 gigahertz. The modern boards are available with the DDR memory, 512 memory, 1 GB memory, 1 GB memory. Again, Raspberry Pi 3 is not the latest board. In the next slide, I'll show you what are the latest board in Raspberry Pi version. Then USB port. This has 1 USB port available, which is USB 2.0. This has 4 USB board. This has micro USB port available. This has 4 USB port of 2.0 available. All are available with HDMI port. Ethernet port is available in B plus and 3B. Then analog video and audio are available. Wi-Fi connectivity is available. You can see it supports 802.11b, G, N, and AC, the latest one. This 802.11.1 and so on. All are Wi-Fi standards. Bluetooth low power is also available, and power over Ethernet is available in Raspberry Pi 3B plus. Okay, so Raspberry Pi is one of the single board computers. If somebody say that what are the other options available? So you can see these are the various single board computers available. Raspberry Pi 4 Model B, then RE Terminal, Rock Pi, Banana Pi, Orange Pi, NVIDIA's Jetson Nano board, NVIDIA Jetson Nano and Jetson Xavier board. These are the, you can say in the famous single board computer, these are the 2 new additions. This is available with a very good processing power, and a lot of help is available from Jetson board. So if you want to develop the applications where graphics card or graphics processing is involved, you can go with this kind of board. Jetson Nano board is around $59. This is $400 around. Easily available in the Indian markets. Gajjar sir has shared a lot of websites with you. You can also find out the reference for this kind of board on those. Raspberry Pi we have already discussed. Then ODC boards are available. Khadas VIM3 board is available. Coral development board, Zimba board, Beagle board. Anybody can ask that how many different such single board computers are available. So there are n number of single board computers are available. I'll show you in the next slides. What you can see here is the different kind of processors available. Jetson board, you can see there are 6 cores available. Jetson Nano 128 core NVIDIA Maxwell GPU is available. Then they are also with the graphics processor unit available. So these are the boards with graphics card available on it. Zimba board with the Intel processor and Intel graphics card available. And you can see the memory available. Raspberry Pi, as I said in the previous slide, we have seen Raspberry Pi with 1 GB, but now Raspberry Pi with 1 GB, 2 GB, 4 GB and 8 GB available. I tell you the practical case. Let's say you want to develop a robot which is a vision-based robot. If there is an obstacle in the path, it has to avoid the obstacle. If you go with a Raspberry Pi 1 GB or 2 GB board, then your robot speed must be very slow so that the obstacle can be detected and can be avoided. If you want to go with a speed which is more than, you can say, 15 or 20 meters per second, then this 1 or 2 GB card may not be sufficient. You have to go with the 8 GB board. If you want to go for the computational intensive robots, then this Raspberry Pi may not work. Then you have to go with the NVIDIA Jetson Nano board or other boards. So these are the various single board computers are available. If you search on Wikipedia, you may see this many single board computers are available. And this slide is also not new. This is almost 3-4 years old slide. So this many, for every alphabet, you have number of boards available. In this list, STM32 board is not available. If you go for STM32, it is also one of the very famous board where with or without OS, you can work with that particular board. It is also one of the famous boards. So this many boards are available. You can choose any board, n number of libraries and lots of material is already available with every board. And most of the board supports the open source community. So that is about the single board computers. So our session has 3 parts: interfaces, single board computers, sensors and actuators. So we are at the 3rd part, sensors and actuators. So what are the different sensors available? So if you are a beginner, then this all sensors are Raspberry Pi sensors available. Arduino sensors available, can easily be interfaced with Arduino. And all sensors, wherever you buy the sensor in the data sheet, they provide all the interfaces, all the libraries and everything available. So there are different distance sensors. There could be temperature sensors, humidity sensors, SpO2 sensors. This is very famous after Corona. Then there are gas sensors, angle sensor, heartbeat sensors, ECG sensors, then inertial measurement unit to find out your XYZ or rotations. Then smoke sensor, vibration sensor, PIR sensors. PIR sensors are very famous. Let's say you want to design a kind of system where no movement in the room is detected, you can switch off your ACs and fans. So PIR sensor are a very, you can say, low cost solutions available. There are color sensors. You must have heard of the line following robots. So line following robots, mainly people, the student deal with black and white lines. But in the industry, there could be green lines, yellow lines or red lines. So there are color sensor available, which can sense variety of colors. Then there are IR sensors for distance sensing. Then there could be the water flow sensors, the petrol pumps and all. When you see that the petrol is given to you, they measure the quantity of petrol served to you. So that is for water flow sensors, or you can say the fluid flow sensors are available. Alcohol sensor, very famous. Then touch sensor, if you want to design a robot, or you can say a telemetry kind of robot where you touch here and the touch is sense or happen somewhere else, then touch sensors are available. If you want to have the gesture control robot, then also this can be used. Then sound and light sensors are there. I have not named a specific sensor because in every sensor, n number of varieties are available. Then actuators and drivers. First thing is the motor driver. If you want to design a mobile robot and it's not a legged robot, then you require the tires. And the tire has to be actuated using BLDC motor, DC motor or AC motors. Then you have pneumatic valves. Pneumatic valves are if you want to actuate something using pistons. I'll show you one of the video where I'll show you the pneumatic valves. Then pneumatic valves are required. Then servo motor, if you want to have accurate movement of your actuation, then servo motors can be used. Then linear and rotary actuators. In your car, when you open your, you can say the bonnet or something like that, there are the hydraulics available. They are the hydraulic actuators. Similarly, linear actuators are also available. they will give you the actuation in a linear motion. Then solenoid valves are available and relays are available. So all those are, you can say, an interface of electronics with mechanical. So there will be some way where your electronics signal would be given to all these actuators and they will perform some mechanical task. So they are actuators or drivers. Specifically, all these actuators, if they require more currents, then only controller is not sufficient. You require some electronic interface between your microcontroller and your actuators. Those we call drivers. Specifically for DC, AC or BLDC motors, a driver is required that will allow your motor to draw more current and it will allow your motor to move in both clockwise and anti-clockwise direction. Same way pneumatic valves, they are pure mechanical elements. So if you want to drive them electronically, then you require interfacing circuits that can also be called the drivers. Solenoid valves, again, they are the, you can say, mechanical actuation, relay also mechanical actuation. These two require an electronic signal. So there'll be a interfacing circuitry in between that can also be called the driver. So those are the drivers. Then there are online applications available. Let's say you want to design a robot which is controlled using internet or maybe cloud or maybe your mobile phones. So these are the various applications available. The first one, Blink, is very popular and it is an open source. You can just type Blink in the Google. It will give you the cloud platform of Blink and it will also give you the help command. They are just drag and drop kind of system. I'll give an example. Let's say you want a button. So Blink will give you a button. If you want to interface a camera, it will give you a kind of, you can say, a monitor. You can put those things in your mobile phones and you can operate any machines from your mobile phones. You need not to write down any code. You put a button, it will generate a code for you and it will send the code on your email address. Just take that code, paste into Arduino IDE and your system is ready. Similarly, all those different platforms are there. Other platforms are not freely available. They are available freely for a small applications for beginners, but Blink gives you a lot of free applications. If you want to develop a sophisticated application with more than hundreds of sensors and actuators, then also you have to pay in Blink as well. So all those information easily available on their websites. So these are the various IoT applications and n number of those applications are available nowadays. Okay, so let me show you some of the demonstration that will lead us to the end of this session. After demonstration, I'll start with the new session. I have 4 to 5 videos to show you different actuator and different sensors. Please hold on for a moment. Let me load the videos. Okay, so this is the first video. What I have done here is, this is for a distance sensor. So you can see that this is the Arduino Uno board. So Arduino, I have used Arduino Uno board. You can use any specific board, but this board, as I have said, is very easy to program and all. So what we have done is, this USB cable is just to power on and program the Uno board. Once the program has been done, you can connect here the 5-volt adapter and it can run independently also. So here there is an ultrasonic sensor which is easily available in the market. You can connect. This is just an example. Ultrasonic sensor, as I have said in beginning, there are different kind of interfaces available. So you can see this ultrasonic sensor is interfaced with the here the pins with the Arduino. It is just a normal digital communication happening between ultrasonic and this. So what we'll do is, ultrasonic means it works in the sound range. So this controller will generate a square wave. That square wave is given to this ultrasonic. That ultrasonic, this two transmitter and receiver pair will send it. It will obstruct with the obstacle, come back, and we measure the delay. And that delay will be calculated and you can display the distance. So what we need to do is, we need not to do the sophisticated coding. The libraries for this are already available. You can use those libraries directly if you are a beginner. But if you want to design a sophisticated code, see, if you are using a ready-made library, then those libraries you cannot modify easily, because there are a lot of files available in the library. So if you want to code on your own, if you are not a beginner designing a sophisticated system, it is always advisable that you write your own code. All the help is always available in the datasheet of every sensors and actuators. But if you are a beginner and want to develop a proof of concept, then the ready-made libraries can be used. And nowadays all sensors and actuator, they provide that ready-made libraries that can directly be interfaced in Arduino. So here what we have done is, we have tried to display the distance. So this will measure the distance, and that distance is displayed on this serial monitor. So you can see currently the distance seems 64 centimeter. So we'll see here. So distance, if we'll bring something near to it, you can see the distance is changed to 5, 7, 10, 14, 21, and so on. So the distance is now changing. Normally ultrasonic can support up to 50 centimeter very easily. Beyond that, it does not support. So this is a normal sensor interface at a single pin serial communication with the Arduino board. This is a pneumatic actuation, as I have said. This particular thing, let me again on my. So this right hand side, let me on the pointer first. This is called piston. This is a pneumatic piston. So what will happen? This piston has a vacuum inside it. And you can see this particular pipe is connected with this particular actuator, and then there is a bottle. So this bottle is filled with the compressed air. So you have to fill a compressed air in this bottle. And this, you can say, there is a solenoid kind of arrangement here. As I have said, there is any mechanical actuation and electronic component, there should be an interface in between. So this interface is between this controller and this actuator, and it also requires the mechanical support. So this bottle has a compressed air. That compressed air via this particular assembly goes to this piston. So this piston has a vacuum inside it. What we can do is, we can activate this particular circuit. This will open or close a valve. This is kind of solenoid valve. It will open or close, and this compressed air through this valve will come into this piston, and this piston will open and close. What we have done is, we have used an IR sensor here. That sensor will detect the distance. If something comes across it, the actuation should happen. So this IR is separately interfaced with this particular microcontroller board. This microcontroller board will activate the relay. Relay will activate this particular system, and the compressed air will allow to get into this piston. Let us see how this will happen. So power is on. As you can see, we put our hand across this IR sensor. The piston is actuating or closing. Every time the actuation happens, the air will be released from the bottle. So after some time, when the air is completely released, we have to refill the bottle. But this is, you can say, a very cheap kind of solution when you require piston actuation. For the sophisticated kind of instrument, you should require a hydraulic kind of actuations. Then this is one more demo of encoders. Encoders are basically used when you want to count the number of rotations. This is a sophisticated encoder which has many pulses per rotation. Let's say 3000 pulses per rotation. Okay, so if your tire rotates single rotation, it will receive 3000 pulses. So if you receive 500 pulses, you can count out that how much rotation your tire has made, half rotation, or you can say a quarter rotation or some degree of rotation. So this axis is directly connected to either your motor or your wheel or your moving assembly, and you can find out how much distance you have covered. So you can see this particular sensor is also interfaced directly with this particular Arduino. Okay, this normally can support UART communication. Sometimes the encoder can also support I2C communication. Depending on the encoder manufacturer, different kind of, you can say, the protocols are available. So here the counts are printed on the serial monitor. Currently there is no rotation. Now we provide the rotation by hand. You can see this many pulses are received when it rotates. So clockwise and anti-clockwise both. The minus sign indicates that it's a different direction. And you might have also observed there is a delay. Immediately it does not give you the indication. So then this particular ticks can be used for further calculation in the controller. Okay, this is the DC motor interfacing. So what we have done, the same Arduino board is used, and the Arduino board is interfaced with the DC motor, as DC motor require high current, and we want to rotate this motor in both the direction, clockwise and anti-clockwise. So we require some circuitry in between the controller and the DC motor. That is the driver. Here we have used the saber tooth driver, very sophisticated driver available. And this driver supports UART communication. So you can see that this motor is interfaced with the driver on the other one hand, where the supply is also connected. On the other hand, the communication between this driver and the microcontroller is using the UART. Okay. At the same time, what we have done is we have connected this PS3 keyboard with this using wireless connectivity. So what we have done is we have used the serial shield available. It is connected with the Arduino. Then as we connect our keyboard or wireless mouse with computer, same way this key is connected here. So this two will be connected using this communication, which is normally, you can say, RF communication. And then using UART, the driver is interfaced with the Arduino and the driver is connected to the motor. So you can see that using this keyboard, we can control the motor. So first we will have to make the connection. So we switch on it and we first start our remote control. So you can see the communication happens. Once the color is blue, the communication happens. Now you can see the motor is turned in both the direction. So this is how you can control any motor. You can control your mobile robots or anything like this. This is one of our machines that we have recently designed. Whatever I have shown, everything is in this. You can see what we want to do. The aim is to throw the arrows. Let me on the pointer. These all are cans located at a different location. What we want to do is this 5 arrows are located inside the machines, already loaded. This we want to throw in these cans. Similarly, some arrows are here in this corner. So machines will go there, load those arrows into these machines and will throw them. So you can see this piston is connected here. I have shown you how the piston is activated using this bottle. So bottle is filled with air. So piston is there. Then Darshita madam has shown you various grippers. So there are various grippers we have made here. Those will hold this arrows. And then there is an actuation mechanism. Then you can see that 3-wheel omni drive is shown here. So that will allow our machine to go in any direction without changing the orientation. And these wheels are interfaced with the microcontroller using the drivers that I have shown in the last video. And both the machines are operated using the keyboard that I have shown, the PS3 or PS4 keyboard. So let us see this video. You can see the machine will go to a predefined location and will actuate and throw, and the person is actuating them remotely. The encoder that I have shown, they are used to precisely measure where the robot is. Did you see how they are loaded? Machine will go there and they are loaded, and then we'll turn them 180 degree. There also we have used the rotary piston. Some of the tasks are done semi-autonomous, some of the tasks are done fully autonomous. Okay, this is one more machine where it throws the ball from left hand side to the right hand side, and then the right hand machine will throw the ball on the other machine. You can see that it will throw the ball and it will catch. Again, similar kind of actuation is there. Now that ball will come up and will be thrown again between two discs. So what all mechanism I have shown? See here, the pistons are there. You can directly see there is a piston, there is air, and just using those piston and air, this particular machine will move like a frog. This is a fully autonomous machine. Nobody is controlling it. So this is end of first session. Anybody has any specific question to ask for session number 1? Then we'll quickly move to the second session. Okay, so somebody has asked, can we use robots for filming movies? See, filming movies requires human intervention. You can move the robot as and when you want, but what to film, what not to film, that robot cannot decide. Even if you add a lot of intelligence to it, that is a difficult task. But yes, if you have a specific things to record, let's say there is a clean room for IC fabrication, or maybe you can say an environment where the temperature variations is very high and human cannot go. You can put a camera, you can put a machine, you can control the machine from outside, or you can automatically control it and you can film something which is not a sophisticated filming. So that is possible. Somebody has asked that are the BLE modules available on Raspberry Pi boards capable of AOA, AOD technique, external peripherals? BLE modules, Raspberry Pi, latest Raspberry Pi has those kind of modules. If not available, Raspberry Pi has a serial communication available where you can interface the BLE modules that I have shown. So BLE modules are available separately that can be interfaced with the Raspberry Pi. But if you are using Raspberry Pi, then you can use Wi-Fi directly. No need to go for BLE modules. Yes, if power is an issue, you can definitely go for BLE. Yes, somebody has given the board ID. There are a number of boards available, as I already said. Somebody has said, what is use of SpO2 sensor? SpO2 sensor is measured your oxygen levels. So the sensor is available, which uses your I2C protocol directly interface to the I2C pin of Arduino board. It will give you the oxygen level of a patient. What is the difference between actuators and motors? Motor, you can say motor is a rotating kind of actuator. So piston I have shown is a kind of actuator and motor is a different kind of actuator. Any more questions? Okay, so let us quickly move to the next session and we'll try to wind up as quickly as possible because we are already running out of time. Okay, so let us quickly move through this design consideration and challenges. So if you want to design your own robotic system, normally I'll be talking of electronic challenges and all. So the machine will have this many things available with you. It will have input interfaces, it will have feedback modalities, and there will be instrumentation challenges. There'll be some safety issues, and there are, you can say, sensory substitutions. So what all are? So input interventions. So there will be a workspace or operating condition from where you are getting the inputs. Then there will be different supply requirement, power supply requirements. Then there will be a different range of inputs available. So what you need to consider? So whenever you design a robotic system, you must consider where you are working. What is your operating condition? Who is going to operate that machine? Then what are the supply available to you, or what supply you want? What are the current requirements? What are the voltage requirement? I'll give you a simple example. Let's say you design an underwater machine which is remotely operated. Now, underwater machine normally does not work on wireless sensors, mainly because of the underwater requirement. So mainly wired machines are used. Let's say you are using a 50-meter long cable with underwater machine, then the supply voltage that you are using may not be available fully at your machine. Let's say you have battery in your hand and your machine is 50 meters away from you, then your 48-volt battery will not provide 48 volt to the machine. So that supply requirement need to be looked at. Then what range of inputs are available? How many inputs? What are the input ranges? Let's say you want to control an induction furnace that's accept input at 600 volt and your controller works at 5 volt. How to convert the 600 volt into 5 volts? Then what are the sensors available? What are the resolutions of sensors available? What is the response time of your sensor and how consistent your sensor is? The ultrasonic sensor that I have shown you, it is a very, you can say, approximate sensor. Its consistency is not very accurate. So it does not make much difference if you measure 11 centimeter or let's say you measure 8 centimeters. But let's say you require the accuracy of 0.5 mm, that sensor may not be used. So what all inputs you are using, that you need to consider first. From where input is coming, who is operating, and what are the different things available. Then what are the feedbacks available? What is the delay in the feedback? Are your feedbacks stable? If they are not stable, how to make them stable? Are the feedbacks are transparent? If not, then how to make them? Then there are some situations which we have not thought of. Let's say you have thought of some obstacles. Somebody is moving on a wheelchair and you thought that the obstacle will come in between. And you put various sensors, but not a camera. Then if there is a very, you can say, a kind of obstacle like a pipe comes in between, you cannot find out whether the obstacle is there or not. Somebody runs through your machine, you cannot find out. So that kind of unmodeled inputs are also possible that we need to take care of. Then some sensory substitution. How you want to convert your outputs. Let's say you want to convert your output into touch. Let's say you want to convert your output into display, or you want to convert your output into an audio, or whether your input is audio or display or your touch, that you need to take care of. You need to take care of the safety issues. So if you are using a visual kind of things, then are those visuals can affect the human eyes or human body. Let's say you are using a laser, then you have to take care of the standard lasers, visible light lasers, and so on. And then there are some instrumentation challenges. We'll see in the other slide. So that all these challenges, input, output, your sensory substitution, your feedback, everything are your consideration when you design a machine. And this all thing you need to put on pen and paper or maybe to your automatic system before you start your designing. What are the challenges? So in the workspace, different temperature range, all your controllers, all your boards, whether they will operate in that temperature range. Then luminosity. Let's say you are using an IR sensor, you are using a proximity sensor. They are very much sensitive to the luminosity. They mostly work in the dark environment. So if you are working in the sunlight, those sensors may not be useful. Or if you want to make them useful, you have to design the ecosystem, or you can say the environment where they can be used. Then what kind of surface your mobile robot is moving? Are there stairs? It's a multi-story building or single-story building. So you have to select. If it's a stair, then you should better go for the legged robots. If it's a single-story movement, then you can go for the wheel robots. Then how far the operator is. If you are using a Bluetooth devices, you cannot go beyond 10 meters. If you are using a Wi-Fi devices, you can go up to 100 meters. not in the kilometers. If you want to operate in kilometers, you should go for a LoRa kind of systems. Then how competent your operator is. I have shown you the PS3 or PS4 keyboard, which are very sensitive. So people who are not competent to operate them cannot use them properly. Then presence and absence of surrounding reference. You are using an encoder, but let's say you are using stairs, encoder may not work. Then how to take the reference of the surrounding things, the reference of the walls, reference of the predefined locations, and so on. And the dependencies from where your inputs and outputs are coming. Let's say your machine takes input from some other machine, and that machine is not designed by you. Then you must take care of the dependencies of that machine. So these are the challenges of workspace or operating condition. The challenges in supply requirement, proper source, whether AC or DC. What is the MAH of batteries? Let's say you are designing a system for some foreign customer and you are using the batteries in Indian environment. Those batteries may not be available there. And if you want to go there with those batteries, then your aviation ministries will not allow you. Whether the charging requirements are satisfied or not. Let's say you are using a machine which carry very heavy load and you are using a 2000 mAh batteries. So frequently you have to charge them. If you charge them frequently, then the batteries will be damaged very early. So the charging requirement is also be taken care of. How availability of high current sources, as I have said, the charging and discharging capabilities. Cable length, I've already said, the cable length and wireless range you need to take care of. Then the range of input, what kind of input you are getting, microvolt, millivolt, volts, maybe sometimes 600, 400 volts. How to convert those input into your available range, whether your input is valid for what time. Let's say your microcontroller sees your input for 2 milliseconds and your input is available for only 2 microseconds. Then that validity need to be taken care of. Synchronization, if you are taking more than one input, do you require all input to be synchronized? That has to be taken care of. Then response time, how fast your input is, how fast your controller are. Then how many dedicated interfaces are available? As I have said, you have 4 sensors which works on UART, but your controller does not have 4 UARTs available. Then you need to move to other interfaces. SPI, normally SPI deal with 1024 sensors at the same time. But if you want to interface more than that, what will happen? You want to interface a display device using HDMI with Arduino board. Then HDMI interface is not available on Arduino board. So what kind of interfaces are available on your board and your sensor? That is also one of the major challenge. Then consistency of input. One time an input is available, let's say you are working with a digital interface. Your analog input changing from 0 to 1 volt, you are getting the same digital output, while you require different output for every 1 millivolt. So your input consistency and stability is also one of the issue that need to be taken care of. Then sensor resolution. If you are using an 8-bit sensor, then your resolution is different. If you are using a 14-bit sensor, then your resolution is different. So how accurate output you require, that will decide your sensor resolutions. Whether the sensor is available in the local market or not, what is the accuracy, whether it supports various interfacing protocols or not. If it does not support the protocols, then the programming would be very difficult. And whether your processor is capable of supporting those programming protocols which your sensor supports, this all needs to be taken care of. Then substitutions. So you need to convert your output into audio. Let's say here, there could be an orange, there could be a green apple, there could be a red apple. The person touches it, and depending on the touch or maybe the camera, you need to identify what fruit it is. So for a camera, it is very difficult to find out whether it's an apple or an orange. Only color may not help. So shape, from where it's banned and so on needs to be taken care of. Let's say there is a number plate recognition system. Then you need to take care of that how the fonts are written. It's a black background or white background or yellow background. That is why you might have observed that in India, we have a policy that the taxis will have a yellow background. Then we have a specific kind of number plates available for sensing purpose. Then there is a thermal sensors available. I'll give you an example which is very acute. Let's say you want to hold a glass. You want to hold a glass using a machine. If it's a glass, if you hold it using a machine, then you must take care what is the amount of pressure you want to apply to it. So there is a separate research going on where people try to find out that if a human holds the glass, what is an amount of pressure that human gives on that glass. And that pressure is identified using the thermal cameras. So that thermal sensors, how accurately you can predict it, then gesture sensors and so on. Here, as I have said, the stick has a kind of sensor inbuilt, but let's say something is coming from this side, then the stick may not identify it. So that is also what kind of substitution of output or input you want to create is also a different challenge. Then instrumentation, the constraint of space for movement of machine. As I've said, it could be a multi-story building or a small building or very small environment when we have to move your machine. So you need to take care of this. Then your machine must be designed to operate at a specific geographical location. That is why we design the all-terrain vehicle. Sometimes you cannot design the wheeled robots. You need to go for, you can say, the legged robots, sometimes 6 legs, sometimes 8 legs, and so on. Maintenance is very important. Sometimes you may not find out the person who can maintain that machine. Sometimes you have plug and play cards available with your machine, but the vendor's monopoly is there. So vendor charges you very high cost. So you need to design them separately. Then the availability of the components in local market, which is a very big issue currently. Now we have the Indian government has stopped the import and export through a specific countries. So there is a scarcity of components. I'll give you a simple example. In one of our consultancies, we are using BLDC motors, but there is a scarcity of BLDC motor in the Indian market. So we need to go for AC motors, which are easily available. But when you go for AC motors, then AC motor cannot be controlled the same ease as the DC motors can be controlled. So now we have to go with the more sophisticated controllers to control the speed and the, you can say, the rotations. Then the issue is cost. Whatever cost you are paying, whether this cost is justified for the available performance or the available output, that is again an issue. As I've said, BLDC motor and AC motor. AC motor, you require AC supply available. If you want to operate the machine at a specific location where AC supply is not available, then that cost is not justifiable. Then standards of the countries. Some of the things that you can use in India may not use in the other countries. Some of the batteries that you can use in India, but you cannot use in the other countries. If you change the batteries, sometime you need to change your drivers also. I have mentioned somewhere Sable 2 driver. It supports some of the batteries with some of the ratings. So that is needs to be taken care of. And finally, the compatibility of the existing mechanism or the workers. You change your machine, you change your sensors and actuators. Maybe the existing machine may not support it, or maybe the people who are working on it, even after training, they cannot work with it. So these all are the different challenges when you design the machine. So this is all from my side as far as the challenges are concerned. If anybody has any specific questions, you can ask. Thank you. Okay, somebody has asked what type of motor is suitable for high torque and low RPM application. See, normally, if you only look at the RPM and torque, then all DC, AC, servo or BLDC, all different kind of motors are available. You can look into your application, availability of drivers, and how good you are at programming. Okay, so if let's say you require very high torque and you have the AC supply available, you should go with AC motors, because then you need not to charge or discharge your batteries very often. But again, as I have said, if you go for AC motors, then the drivers for AC motors are very difficult to handle. BLDCs are now very famous because it requires less maintenance. But again, BLDC motors, as I have said, are not easily available. So DC and BLDC both with high torque and low RPM is available. So depending on your application and availability of components and your ease of programming will decide what kind of motor you should go for. Okay, I don't see any more questions. Okay then, so this is all from my side. Thank you very much. If you have any more questions, you can always email us. Thank you.
Thank you, Dr. Nagendra Gajjar, Dr. Darshita Shah, and Dr. Akash Mekwan for sharing this valuable knowledge on robotics.